This session is going to be very interesting, so let's hook up. We're going to talk about AI and how how AI can help on interoperability and data exchange. So I would like to thank you for all the participants to be here, and for those that listen online to tune in. My name is Marcello Grita. I'm an external team member of the DigiDigit SEMIC team. I focus on data spaces, AI for interoperability, and digital sovereignty. And today with Brooke, we're going to be the moderator for this session. Now, this session will be packed, so it's probably better to start with the agenda. We're going to have a nice and rich perspective from all sides of the spectrum, from the research side and deployment and real use cases, from the public sector, private sector, and academia. We're going to start, we're going to kick off with George Lobo, a team leader of SEMIC, with a nice introduction, and then forward-looking on what's around the corner for AI, and followed by ongoing activities of SEMIC and the JRC. Afterwards, we have a couple of practical examples from the Netherlands and Germany on how AI is applied for semantics. And before, obviously, each presentation will have will be about 15 minutes plus Q&A, timing if time allows. After the breaks, we're going to have semantic interoperability presentation on large language model for EU, and eventually from the private sector. So before going to the panel discussion. Great. Brooke, do you want to take over?
Welcome, everybody, and also welcome to anybody who is watching online. Please, we have a Slido. For those who don't know a Slido, you need to get your phone out, scan the QR code, and then we're going to have a lot of fun with some interactive graphics. So please, everyone, jump into the Slido for me. So we have so many people in the room, really a lot, and I see a lot walking around the corridor. We're just really interested to know where you're coming from. So where did you fly from? Where's the country of origin?
Vienna is the first one, Germany, Belgium.
The Netherlands. Very good representation. Belgium.
Sweden.
Ukraine. We've got some locals here for Copenhagen. Italy. Bravi.
Belgium seems to be winning.
So yes, we're from the capital here. This is really great. It's great to see such a diversity in the room as well, because this brings in a lot of knowledge and information for us all. And we will go to the next poll. Taking on board the fact that there's a lot of people in the room from a lot of different countries, we're really interested to know here how you're currently using AI within your organization today. You are using it, yes, that's great. Let's elaborate a little bit.
Risk in policy, everywhere. Interesting. Summarizing education, interesting, nice use case on education. Copilot for the wall stuff. I suppose Copilot more for
the Copilot is the internal one.
Vibe coding. With caution.
Carefully, yes, that's it. That's very interesting. Experimentally, deep research. Research seems to be...
Experimentally, GraphRag.
Yeah.
We're getting into something.
There's a lot of different ways everyone is using it. This is not allowed to yet. Oh, dear.
Yeah. I wonder where.
Ah.
Where is
we want to see that country. Where are you not allowed to just yet? This is great.
MCP.
And the final one that we want to see, because you're using it in a lot of different ways, fraud detection, very interesting there. So how would you like to see AI improved in use and application within your organization if you're allowed to use it?
Yes, it's an interesting question.
Proofreading.
Already forward-looking.
Yeah.
training.
The RAG. Sovereign AI.
Accessibility of information. That's why we're here.
So the RAG and sovereign is really coming out here as one of the leaders.
Sovereign AI. We need a better definition of what do we mean by sovereign AI.
What is sovereignty coming out? Exactly. Very interesting. A sparring partner. Who wrote that one?
I do actually have a project for a sparring partner.
Fantastic.
But I have to correct it a lot.
Great, this is fantastic. So thank you so much. I think a lot of these questions you'll see coming out and where you are in a lot of the presentations that we're going to be having across this very full session. And to start us off...
Yes, the first speaker will be George Lobo, who's going to talk about semantic and AI evolution or revolution. Okay, George is a program manager at DigiDigit and team leader of the SEMIC team. George has worked at the European Commission for over 24 years in IT, digital technologies, including Internet of Things, network technologies, smart cities, just to mention a few. Before joining SEMIC, he led the digital innovation and in the public sector, the GovDev initiatives, and Interoperable Europe Academy. George, the floor is yours.
Thank you. Do you still all hear me? Yes? Okay. So I will first introduce to SEMIC what we're doing in SEMIC. So, I mean, I did the same in another workshop this morning. So our work is since more than 13 years to promote semantic interoperability among EU member states, mostly public administration. And it's what we're trying to do is to promote and reuse semantic assets and experience and tools, and also to identify opportunities on alignment of semantic solution. The way, I mean, since we're talking also about sovereignty, and I think open source is one of the way, I mean, the important letter in SEMIC is the last, it's the community. So it's a common effort. So it's we have a vivid community on the Interoperable Europe portal, but as well on the GitHub, where people can make comments that can participate to the elaboration of the semantic assets. And of course, we elaborate on the importance of data and metadata management. And here it's just describing most of our work. So it's mostly about specification. It's our core work. So to work on core specification, mostly application profiles, and as well on core vocabularies for public administrations. We do also some pilots, either to experiment on a new technology or to trial, as we do in AI. I mean, we do a lot of pilot and experimentation, and of course to spread the gospel, I could say, so to have the knowledge hub, so where we have courses, we organize webinars. I mean, I would say in the last 3 years, we organized more than 45 webinars. So it's something that is also taking a lot of time, but we have also encouraged by the attendance, as today we have also a lot of people here. Here are some of the focus area we are into. So it's mostly, I mean, we are been discussing, for example, on data space, catalog of service. But the last point is where I will be more focusing. So it's AI for interoperability and interoperability for AI. So I would say on interoperability for AI, one of our main achievements is an extension of the DCAT-IP metadata. So it's ML DCAT-IP for modeling language, and it's a semantic model in the field of machine learning. That is, objective is to ensure that the use, I mean, to extend the use of DCAT-IP to have the core information that you will find in a DCAT-IP metadata, but as well to ensure that you can have the metadata on the description on the large language model, the algorithm, and as well the training data. So these are possibilities, metadata as you can put into this specification. And we believe that adopting this would make not only that it would help to adopt this extension to get more discoverability on large language models, but as well because we build it based on the AI Act. So it has the provisions on the AI Act. It contains all the provisions. So it's also helping, I would say, people who would adopt that as well on the, I would say, the reporting obligation that comes from the AI Act. And on this, I mean, you can see we have a number of trainings and videos where we have learning materials. We are also doing some proof of concept on the hood of AI. I mean, like annotations, thesaurus. We are also doing a number of research. There are also, I mean, you will see a presentation of some more deeper in some work. And I think I will not take much of your time because that was just the introduction. You're here to listen to very interesting talks. So here is my contact. You can contact me. There is a website which is called website. That's easy. But in any case, if you go to our, I mean, my last word would say that, as I mentioned, SEMIC is first of all a community. So we really, I mean, we need the people. We need the expert on the domains. We need the expert on semantics to help us to shape the specification. So you will see at the stand, at the booth, there is a flyer where you have the link to join the community on the Interoperability portal. And also I encourage you also to see on GitHub what we are doing, to put your comments, and also to propose new ideas. Thank you.
Question and answer. Thank you, George, for your presentation. I just want to remind everybody, while you're in Slido, if you actually saw, there is a section where you can do question and answers if you want to. So please, at any time when you feel you have a question to be addressed by a presenter who's currently presenting, or later when we have our panel, please just pop it in there, and the moderators will be able to find. Our next speaker, who will be speaking on AI and the future of semantics and data interoperability, is Mr. Edward Curry. So please come up. So Ed Curry is a professor of data science and director of the Insight SFI Research Center at the University of Galway. He specializes in semantic technologies, data management, event processing, and distributed systems. He is the co-founder and vice president of BDVA, Big Data Value Association, and ADRA, AI, Data, Robotics and Association, contributing to Europe's data and AI science agenda. Thank you very much, Ed. Looking forward to your presentation.
Thanks very much, and I've been introduced. So I'm going to talk a little bit today about AI and data. So I'm going to take a pretty high-level perspective. So don't worry, there's no formulas, there's no algorithms, there's just a gentle introduction, and we're going to have a lot of deep dive talks later on as well. But when I was asked to come and talk, the first thing that came to mind when you think about SEMIC is data, data management, interoperability, community. And I thought, well, where are we with this? So I went online and I went to look for kind of a state of play for data management and different technologies that are there. And I came across, as always, one of these Gartner hype cycles. So this is from last year, so it's a little bit out of date, but I think there's some really interesting messages in here for us. So for example, a topic close to my heart, event stream processing, something I did my PhD in about 15 years ago, maybe 20, is at the plateau of productivity. Things like data engineering are now seen as important key elements within enterprises, which I think is very important for this community. Things like knowledge graphs are starting to move into that area now, where they're becoming much more commonplace beyond maybe the niche audiences that they were in before. And then you see some other things like the data mesh. Do you remember that conversation for the last couple of years? Lots of blog posts about data mesh. Well, apparently that's obsolete before it's even started. But there's another couple of interesting things here as well. Like there's this vector databases, which I think are quite important in terms of RAG type systems. You'll probably see a lot of them later on. But things I wanted to point out here were data product, which I think is very important to this community. I'll talk about that later on. DNA governance platforms, that's data and AI governance platforms, which I think is critically important. And then the topic of this panel, this entire session, is something that's just kind of been triggered there, as you say, generative AI for data management, or AI for data management. So a very hot topic, but very early in the stage of this innovation, which could potentially run very, very quickly. But where are we in the area of AI and AI adoption? So over the summer, this is a report from McKinsey that looked at what's the state of play for generative AI within industry. So they surveyed about 2,000 business leaders, and what they found was that 80% of the respondents had deployed generative AI in at least one business function inside their organization, which is quite impressive, I would say. What they found is that most of them are at the pilot stages, so they're early stages, they're not quite mature yet, there's challenges around scaling them. But potentially most worrying is that if you look at this chart, what you find is that the grey boxes are people that don't know if they've got value or they've got no value yet. The majority of organizations are not seeing any benefit from deploying generative AI solutions yet. So that's a key challenge that we have, and a key issue. There's definitely a disconnect between the expectations of what business leaders think this technology can do and what the AI can actually do. And that's where I think we're going to dive in and have a look at that to see how do we start trying to move more people towards that kind of value category where people see benefits directly from that. So it's important to think about the relationship that we have between data and AI. And we very much have this symbiotic relationship between data and AI, and particularly around data spaces and AI. And I think in the last 3 to 5 years within Europe, we've seen a lot of developments in this space. Things like the AI Act, and more recently now the Apply AI strategy, AI in science, AI factories, significant investments on the AI side and on regulation. We've also had the European Data Strategy, which is about 4 years old at this stage, and last week we had the European Data Union just announced as well, which refreshed that and kind of brought it closer to what we need for AI and started to join some of these blocks up. But there's a very, very symbiotic relationship between these. So the same side, the different sides of the same coin. What's critical for AI systems is to have high quality data, is to have data you can actually use and have consent of for training AI systems, and data spaces provide us with a framework to be able to provide that. So high quality data that's coming from a community of data owners, data users that have given permission through a clear governance framework for that data to be used in the training of AI models. What AI gives us back is that capacity to be able to extract value from data. And that's been a key challenge that we've had. And I think when you look at most of the sessions that we see today and in the and tomorrow as well, you'll see a challenge around working with data, interfacing with data, using data and extracting value from data. And what this session is about is understanding what's that potential for AI to help us to do that. And we've seen many examples of it, and we'll see many examples of it today. And I think that that's a key opportunity for us. But we're also seeing an evolution in the types of AI that we're talking about as well. It's no longer algorithms on a particular machine, but actually you're looking at large language models, and we're starting to look at things called agents, which is quite interesting as well, because what agents and agentic frameworks are bringing us is as actually a very simple interface to how we interact with data. So the notion of querying a database may be a thing of the past. It may be just a question to an agent. Get me this type of data, do this to it, give me a report. We're effectively on that precipice today. What's important to look at here is that there is a value chain around agents. They don't just appear out of nowhere, but rather there's actually a clear value chain going right back to the data. And it's critically important to know the role that data plays here. Going back to that survey from McKinsey, when they identified, a lot of organizations having challenges to scale AI, they asked them, well, what's the challenge you have? And they all came back with answers around data, data quality, data governance. The business leaders didn't trust their data. They didn't know where it came from. They didn't know what type of quality it was. They didn't know if they could use it for certain reasons. And that's a really interesting thing, because if you're looking to have an AI or an AI agent make autonomous decisions for you using data, well, it's hard to expect them to make the right decisions if you don't trust the data. How can you trust them to trust the data? So it really emphasizes the importance and the centrality of data and data governance to actually enable these types of visions. And what this really means is that we need to look at how we bring together the data lifecycle and the AI lifecycle so that we do have these end-to-end systems, so that we don't just think about how do you manage data, how do you curate it, how do you have data quality, without thinking of, well, what type of AI models will I build using this? What type of agentic systems will we deploy? What type of tasks will that solve for our business users? What type of questions and decisions will our users want to make using that data? So what becomes critical is bringing together that end-to-end life cycle so that we look at data from the point of generation or collection, and that we have that use, that end use in mind from the very, very start. And the same way when we're actually making a decision and we need to ask how much do we trust this decision, how much data and evidence can we provide to be able to support that decision? Well, where did it come from? Do I trust it? Do I trust the governance? Do I trust the data quality? So end-to-end data management becomes quite critical. And this is an example here of a very simple life cycle for a data space connected to an AI pipeline and looking at how you manage that from start to finish, recognizing that AI systems are significant generators of data today as well. So what does this mean in terms of the challenges that we have and the things that we need to try to sort? So within the BDVA, we've been looking at the notion of AI-ready data products. So again, looking at what Gartner identified there as data products as being something that is reusable, that's trying to simplify the ability to be able to exchange data between individuals or organizations. The notion of a data product is that you have a very clear purpose for what that data does. You're packaging that data so that it's easier for it to be reusable, to be findable, to be accessible. We know what all this is in this community. This is what we've done for many, many years. But this is a new unit of exchange that we can start to look at. Within the BDVA community, we started to look at, well, what do you need to have an AI-ready data product? What are the AI-specific requirements that you need on a data product to make it suitable for building AI models and for powering agentic systems? And what you see here is there's a white paper currently being constructed by the community, and some of the key things that we were identifying here is like metadata, data quality, data provenance and lineaging, licensing, conformity. Very, very similar things, actually. And George, on his slide, had many of these things up there as well. This is something that this community has been doing for years. And when we look at what does it mean to build a data product, what does it mean to have an end-to-end life cycle? Well, actually, it's metadata and the standardization of that metadata around that life cycle become critical, because that's the governance layer, that governance plane that ties the creation of the data to the use of that data and brings the provenance and that metadata the whole way along. And that's critical. We're seeing some very nice work coming from industry in the area of croissant. We have excellent work here from the SEMIC community around DCAT AP. And this is a real opportunity for us to be able to understand what are the tools that we have, how are they now relevant in this new world where we're going to be exchanging data products, where we're building agentic systems, and where our organizations are clearly identifying that data quality, data governance are the key barriers to scaling AI systems. So I think there's a real opportunity for us and for the community. The other big thing that we do in SEMIC, and it's the first word, is semantics. And we're talking today about AI and its role in the interoperability of semantics, but it's useful to think about what's the real challenge with semantics, right? If it's easy to come up with a common conceptualization of something, there's no problem. But why is this such a hard problem to solve? And it's a lot to do with the fact that semantics themselves are subjective, right? Everyone looks at the world, they conceptualize it in different ways, different perspectives, different valid conceptualizations of the world that are perfectly acceptable. Even though they conflict, they can still be acceptable to that particular community. And you particularly see this in large organizations where you have the accountants that model the world in one way, you have the chemists that model the world in another way, the engineers, the mathematicians. All of these different disciplines, these different functions have different ways of viewing the world, because as professionals, they've been trained in a particular perspective, in a particular mindset for how you picture the world. All valid, all acceptable. But the notion that you're going to get a single coherent perspective on reality or a model of reality is very, very challenging and probably impossible to do. So that's really important, is to recognize that our systems have to accept ambiguity, they have to accept vagueness, and at times inconsistency in that semantic modeling of what we do. Where consensus is possible, that's great, but you can't expect 100% consensus or 100% compliant for an entire system. The other challenge that we have today is around subjectivity itself, subjectivity in the data. subjectivity in how we query the data. So here's a research paper from a couple of years ago that looked at the level of subjective data in different domains, primarily around reviews, which is obviously quite subjective in itself. But the challenge here is, if I query for a hotel, I'm looking for a hotel in Copenhagen, I like it to be reasonably priced. Well, as a professor, my subjective opinion of what reasonably priced is one thing. If I'm a billionaire, that's a different thing. If I'm a student, that's a different thing. So you've got this notion of subjectivity, my subjectivity versus yours, and that is something that's actually baked into an awful lot of our data, and we have to be able to recognize that. We have to be able to build systems that can manage and understand how we deal with subjectivity across the different points. The other challenge with semantics is that we are always creating more and more complex data. It's a constant race, it's an evolution, it's a war against more data being created, and what data management tools can we bring to it. We've gone from scenarios 20 years ago where we could fit entire data models into tables, where today that's not really realistic. If you think of the ambitious goals that we have around things like Destination Earth and digital twins of the planet or digital twins of a human, you're not looking at tens or hundreds of attributes, but you're looking at millions of attributes that will be associated with these models. So the complexity of the data is increasing, the level of multimodal data is increasing, and our systems need to be able to manage and work with that. And all of that adds more and more semantic complexity, inconsistency, ambiguity, and data quality. When we look at this from a management point of view, well, if you go back to, people might remember this, but Halvey, Franklin, and Meyer produced a data spaces paper about 20 years ago. And they analyzed things on this notion of administrative proximity versus semantic integration. This is a classic image that I've shown a few times, but it's really important to understand this. What level of integration do we want? If you want to have high levels of semantic integration, you need to have a lot of control over that data. And that creates cost. Fundamentally, that creates cost. It's high cost around the coordination, high cost around the semantic integration. That limits the scalability of it. At the other extreme, things like web search, you've got very little levels of semantic integration, you've very little levels of coordination, and that enables scalability. And that's a key challenge that we have to look at. The way that web search is able to do that is because it does a computation across the data. When we look at open data portals, we've got some levels of coordination, but primarily at the semantic level, data sets are primarily independent. The question around data spaces, I think, is still open. Some of these data spaces, as I heard today, a few examples talking about star models, looking at incremental, minimal amounts of conformity that are required. Other data spaces are very much top-down. You must conform to as much of this as possible. This is an open question for us. But I think it's actually the central question that we have within this session. Can AI help us to scale semantics? Are we able to do that? So some work on this in the area from the Data Spaces Support Center. They've done an early paper on the role of generative AI in data spaces, where they analyzed the opportunity for data spaces to power generative AI models and also generative AI models to be able to power data spaces and other types of tasks. The white paper, it's a very good read. I'd recommend you to take a look at it. But in summary, what we say is that there's significant opportunities for generative AI to be able to support data management and data spaces. So this is an example here of the blueprint from the Data Spaces Support Center, and we can see that in the area of technical building blocks, there are lots of opportunities for generative AI models to be able to provide tools to enable those tasks. But also in the business and the organizational building blocks, there's significant opportunities as well for generative AI methods. In the following talks that go on, we'll see a number of really cool examples of where Gen AI and AI models have been used for data management tasks. But last year, we actually tried a very early proof of concept on this. Could we get good enough interoperability using LLMs? So we gave a very simple prompt here, basically asking for this data type, could you give us basically a shackle shape? We popped it into GPT-4, and we actually got a very reasonable attempt at actually generating the shackle associated with that data type. So the answer here is that there's significant opportunity in AI to help us scale semantics in the space. We've seen a lot of talk about RAGs, and basically when we start looking at these end-to-end models, we've done some work on bringing together RAGs over data spaces to be able to leverage the data governance framework within the data space to help us have trustworthiness around our RAG and to be able to understand where those answers come from and to be able to help have more faith in the actual answers that they're giving. So I'm really looking forward to those talks later on. But my final few slides, what I want to talk about are some of the maybe further opportunities that we have in this space as well. So particularly looking at the role of semantic agents for data spaces. Can they actually operate as an interoperability and mediation layer for us? Can we actually ask our agents to be able to negotiate the difference in semantics between different mapping systems? Can we use agents for knowledge synthesis and reasoning? Are they a way to help us to improve this human data interaction so that we can make it more frictionless for users to be able to interact with data within a data space? And can we even use them to be able to support the coordination and the management of the data space systems themselves? What's interesting about the agents themselves is that if you want them to be compliant with the AI Act, that actually gives us an awful lot of opportunity to simplify the implementation of that regulation as well. So rather than humans having to interpret it, can we actually empower the agents to understand what the Act means and then to put that into practice in their day-to-day operation? I think key questions for us is, can we look at LLMs and foundation models to help us scale semantics? Can we support more data, more use cases, more diversity in what we're doing? Does an LLM actually require us to even rethink the fundamental nature of what knowledge representation is? Could you provide a universal representation of all our data through an LLM? It's an interesting open question. What does data quality mean in the world of LLMs and foundation models? How do we measure it? What's the value of it? Does the data curation pipeline change because of that? And then I think finally, how do we test these subjective systems? How do we actually understand subjectivity and test to see if our systems are actually able to accommodate that and to work with that? And then a little bit of a call to arms, last two slides. So a couple of years ago in SEMIC, the community organized a number of workshops for personal data spaces. And I think if you look at the state of play in the last kind of 12 to 18 months, what we started to see is that we've got some early deployments of our common European data spaces, large scale, bringing together large consortiums of organizations, designing this infrastructure, and they're starting to go into deployment. I think it's important for us to consider, well, what does it mean once these data spaces are in play? How does the individual manage their data? How do they work with their data? And I think we need to go back to start looking at our personal data spaces. And recently at the International Semantic Web Conference, we had a workshop on trustworthy autonomy, accountability for personal knowledge graphs. And I think this gives us a kind of a clear role and a clear roadmap for personal data spaces to understand for the individual, how can we empower them to manage their data, to be able to interact with common European data spaces, and then what are the roles of agents within that as well? Can you actually have an agent represent you and your personal knowledge graph within a common European data space? Think of the idea that we have around GDPR. So we have GDPR that's led, for many of us, our day-to-day interaction with that is working with cookies, and we get the cookie tax, and people get tired of that. But there's no reason why an agent, we couldn't express our preferences around cookies to an agent, and our agent to be able to handle that interaction with every website to say, yes, you can have these cookies, no, you can't do that. So I think we've got a great opportunity to think how we can implement governance, how we implement data governance using these types of agent technologies, particularly around personal data. And with that, I will pass over to Marcello.
Let's take a couple of questions.
Are there any questions? Are there any questions from the audience? Absolutely. Can we have a microphone, please? Thank you.
Thank you. This is Claudio Baldessarde from SEMIC. So the idea that we can't have semantics that works for everybody, that somehow it's an individual or a subjective work, after 20 years, I can accept it of the Semantic Web project. And then the question is, instead of materializing semantics, formal semantics into assets like ontology can be, what is the opportunity of having semantic as a transient contracts between agents that use it for a task, and that dissolves back into the ether. So the idea would be that for a certain task, and you have mentioned negotiation of meaning. This negotiation is implemented with just a temporary expression of what is the truth or what is that domain, and then once the operation is done, then it dissolves back into agents that somehow floats into the space. Would that be reasonable to think about semantics that is not fixed?
I think it's an interesting question, Claudio. So the way I would look at it is that the challenge that we've had with semantics is that we're looking for a single view of the world for everyone to conform to. And maybe for half of the semantics we can do that. So a large percentage of it we can. I think the opportunity now is that once you have that common agreement, what you now have is areas that you don't agree. But chances are I can agree with you on something that we can exchange and have a transaction on that, and I could agree with George, who's gone somewhere over there, and we could have a slightly different agreement, but that we wouldn't necessarily have to get all three of us to agree on the semantics at the same time. So I think it enables more point-to-point exchange that will be sufficient for the very specific task that we're engaged in. So rather than having to bring everything and have full conformity, I think it opens up the possibility of having more incremental point-to-point agreements between organizations and individuals around very specific semantics. So it allows us to kind of decompose the problem into smaller chunks. It's a perspective. Yep.
We have an online question for you. Do we need semantic MCP?
Do we need what?
Semantic MCP.
Absolutely. Absolutely. So I've had another hour I could talk about this. I think MCP is it's a model context protocol. For many people that kind of started on this semantic web vision 25 years ago, it's a massive step in the direction of enabling that, because it basically gives us this connector architecture. It's maybe a little light on semantics, but what it has in spades is this notion of adoption. So it's been driven by industry. I think it gives us a base layer to be able to provide these connectors very simply, but it doesn't have things like governance. It doesn't have things like higher semantic modeling. And I think those are now opportunities for us to be able to leverage that as a core foundation and then to build additional layers on top of it. So absolutely, I think that's a great chance for us to actually realize the vision of the semantic web. And the key thing there is that it's now driven by industry. So as researchers and as people from the SEMIC community, what's important for us is to bring our years of expertise in data governance and metadata and understanding how things can work and how things can't work to inform that conversation and to guide it in the right direction.
Thank you.
Thank you very much. Thank you, Ed, and great presentation. I have tons of questions I will ask during the panel, including your questions I will ask to the panel, back to yourself, to the panel. Now it's time for AI for interoperability under the SEMIC action. Presenter will be Weyts and Emilien Caudron. I hope I pronounced the name correctly. Ine is a technology consultant in the cloud data and AI team at the PwC Belgium. She specializes in responsible AI, data analytics, and semantic interoperability, contributing to the SEMIC team with work on data spaces, MLDKTP, and GraphRag, among others. Emilien is a technology consultant still at PwC Belgium. He specializes in artificial intelligence and semantic interoperability, contributing to the SEMIC through chatbot development, automated semantic labeling, interoperability studies, and optimization of large language models. Emilien, please.
Good afternoon, everyone. I'm happy to talk to you about the SEMIC activities we perform relating to AI for interoperability and interoperability for AI. So in SEMIC, we really tried to keep this tandem as closely knit as possible. So we really have, as I already mentioned, AI for interoperability and interoperability for AI. Say that 5 times in a row. So we're working on proof of concepts, studies, research, and also on the interoperability side. And MLDCAT-AP is one of the things that I would like to talk to you about today. So MLDCAT-AP, a machine learning DCAT-AP, so a data cataloging application profile for machine learning models. As Georges already mentioned, we have several key pillars, and this one falls into the latter one. I hope most of you know that we have DCAT-AP, and the machine learning model DCAT-AP is an extension of DCAT, so it follows all the same statements and things, and we also aim to tackle the same issues, like the lack of semantic interoperability to communicate about different assets and exchange them as well. When we're talking about data exchange, we have on the one side the data provider and on the other side the data user. And they both have different requirements and different needs. So, for example, you have a need for transparency, a need for reusability and findability as well. And they can exchange their information on data platforms. And you also have the AI Act that came into play this summer. It entered into force. So we need to act to make sure that the providers and the users both have the things that they need when they talk about machine learning models. So that's why we started working on MLDCAT-AP. MLDCAT-AP is a specification that already exists for quite some years now, although it's still a very new specification amongst the others. So we had the first release, 1.00, in 2023, after a pilot in collaboration with OpenML, and we started reusing DCAT-AP concepts to talk about machine learning models. Then we decided to expand a little bit and do a comparative analysis between different repositories of machine learning models, such as Kaggle, Hugging Face, etc., and to also align with DCAT-AP. So we made a new version. And then, when the AI Act came into play, we made another minor update to align with different annexes talking about machine learning models. So we included several different classes for this. And now, there was also the AI Code of Practice, a policy guideline that added all new elements. So we made a new version of MLDCAT-AP 3.00 that was released in September, and it also aligns with DCAT-AP 3.0.1. So in summary, there are many different sources for the latest version of MLDCAT-AP. We have the legal sources, such as the AI Act. We have data model sources, such as the DCAT-AP. We have different data models, LPWC, DPV, etc. And then we have the policy side, which is the AI Code of Practice. I will let you know in a little bit more detail how we took those into account. So on the left-hand side, you see a screenshot of the AI Act, and on the right-hand side, you see a screenshot of the MLDCAT-AP specification. And here we really linked the different aspects that align. So for example, you see that in section 1A, the tasks that the model is intended to perform are translated in the model specification into 1A, intended use as well. So we really map almost a one-to-one mapping of how we think that you can talk about these requirements in the AI Act as well in your semantic models. We did the same for the AI Code of Practice, and we took, again, on the left-hand side, you can see a screenshot of the AI Code of Practice, and we took various different elements from there, and we added it to the specification. In the specification, the most right column, it has a reference on where we got the input from to add that element. So here, for example, you can see that it's almost all AI Code of Practice, of course, because it's a slide on the AI Code of Practice, but you also have a few that have DCAT-AP as well in there, so this also links back to the data models there. And that's a very brief introduction to the interoperability for AI part of the SEMIC activities, which was machine learning DCAT-AP. And I will hand over to my colleague Emilien, who will tell you a bit more about the AI for interoperability part.
Thanks, Ina. And indeed, here I want to talk a bit more about what the different proof of concepts research that SEMIC is doing around AI for interoperability, with one specific example that focused on how we can help semantic modeler, data modeler, to develop data models that could be more interoperable. The key problem or question that triggered that research was there's more and more data models that are created, really an explosion of standards that come into play. And if you want to ensure that you have as high interoperability between data models as possible, you would like to reuse as much as possible what exists, avoid to reinvent the wheel. But with the mass of information available, it becomes more and more complex. And that's why we thought, why not use an LLM to facilitate this access to information and be able to answer or recommend a specific class or a specific property that one could reuse for modeling in a specific use case. So that was really the starting point. And based on this, we thought, why not create a solution that integrates better in the whole data modeling process, and have actually a tool where you could upload a data model, chat with it, brainstorm about it, leveraging actually the power of a classic LLM to have discussion and have creative ideas on what could be missing to cover my use case. Also, and that was the key, having the possibility to search to a set of existing concepts, a knowledge base where you could put some controlled standards on which you rely, get a visual overview, or even make some modification to the data model. So that was really the purpose of this tool that we developed, this proof of concept. And so the basis is really this knowledge base of data models. We focus mainly on SEMIC specifications. So here I put a few examples from those: CPSVAP, CPOV. We put also some regulations so that the tool could be aware of the regulation around it. Plus a few collection of data models linked to open vocabulary schema.org to enrich it a bit and makes it recommendation more broad than possible. Then in terms of technical aspects, to be more concrete, to orchestrate all of that, we decided to leverage MCP, not in the first version, but in the latest development. So for the moment, what we have is an MCP server where we have an LLM orchestrator that can access then a real toolbox with the different building blocks that we decided to create to help it answer the question of the data modelers related to the specific use case. I put some example on the slide. So a tool to search through a knowledge base, to modify a data model, to visualize it, to read the data model, and extra tools that we are still developing. Now, enough talking, let's take a look at the tool itself. Normally this should launch it. So you can see on the slide, so the starting point of the tool is really uploading your data model. So here with an XML file, the chatbot has access to it. You can get a quick overview, visual overview in UML, human readable, to really see what's inside your data model. That's one option. The other option, I mentioned it as, let's leverage the LLM to just chat with it. It can be simpler, especially to identify one specific aspect of your data model. So here simply asking, what are the different classes of my data model, to understand, okay, what do I already have here, and what could I be missing to cover another use case. You can have a high-level view. You can get deeper understanding, asking the tool to show more information about a specific class. Here I take the example of the class person that I have in my data model, to see exactly what are the properties that I have, what's the definition, and see what I already cover here. Now, next to that, and that's where it becomes interesting, is I want to be able to brainstorm about it like I do in ChatGPT or any of the AI tools that we have today. So if I have a use case in mind, I want to be able to brainstorm with the LLM, taking into account my data model. Here, let's say I want to extend this data model in a specific case here, the medical domain, an hospital. Let's ask what I would be missing to model a patient. Here there's two situations. One situation is just, I just want to brainstorm. I don't want to bother about what exists before, so just a simple LLM discussion. And that's the example you have here at the moment, so really describing all that could be possible in terms of without restriction here. Of course, the more information you give it, the better will be the list. And the other opportunity, and that was kind of the objective of the tool, is what already exists in other data models. And so here that's the question I asked to be more specific. Okay, I want to add those properties. Did anyone else before already thought about it? Should I not look at it? And so you see here what's happening is that for the different properties that are mentioned, it's going to make a research into the knowledge base to see, okay, what's already available. Here it started with date of birth, then it continues with the next one, and it can go on and go on and go on. Here in that case, it decided to stop to be sure that it was on the right path. One of the advantages here that we have is you can see for every tool that the LLM is calling, you can see exactly what was the arguments that it used, what is the documents that it retrieved. So you have a traceability on the information it used to generate the answer. And once you review the different elements, once you reviewed what was there, you can make modifications. Here asking simply to add the different attributes to my classes. And as I mentioned, and that's what's going to be shown on the slide, is if you go over this, you can really, and that's really one of the advantages of this MCP architecture, you can review exactly what are the tools that were used by the LLM, see what are the arguments that it used, what are the outputs that it generated, so you can really track back what's possible. This is a simple flow. Then another thing that we have explored is how we can use this to check a bit more compliance towards some criteria. So here it's a simple example just to show the possibilities. So you ask a more complex question, such as how interoperable is my model, but and then the tool is able to make a plan, and once he has a plan that's validated, to follow it, to perform the different action using the tools that you have defined. So once you have a set of criteria for something specific, for example, one thing we are exploring at the moment is how the SEMIC style guide, which is one of the assets of SEMIC, we can use the LLM to check compliance towards this asset. And so defining those criteria and defining the tools accordingly, you can have the LLM really support you in this more complex process while still having a view on what are the tools that it uses and reviewing the quality of the output. That's going to be it for the presentation of this POC created by SEMIC. We are doing a lot of other things, so if you're interested, don't hesitate to reach out and ask any question. Thank you very much.
Thank you. Thank you, Ine. Thank you, Emilien. Let's first see if there is any questions from the audience. No, at this stage. I have a couple of questions. Maybe we can check also online, but I have a couple of questions. I'll start with Ine. You were mentioning, obviously, ML-DKTP. Obviously, standardization is very, very important. You went through different cycle of our different version. So what's next in terms of is any new version coming up? And is any contribution allowed for this, for ML-DKTP?
Contributions are always more than welcome. We have a GitHub where you can submit issues and where we can discuss different things in the specification. Next versions are not planned at the moment. We keep following the latest other developments to see if there's a need for any major or minor releases for ML-DKTP. But additionally, we're looking for people who want to implement it, so we're actually looking for use cases and pilots. If that's anything you would be interested in, please come and find me, and we can talk about it a little bit more. So at the moment, our focus is on pilots and having ML-DKTP being actually used, and then the next steps of continued development will follow from there.
Thank you. And my next question is for Emilien. So I'm intrigued by the toolbox. It's referring also to one of the earliest questions. So you have this coordinator, and you have several, I'll call them module or tools. Are they also agentic? Do they also use AI? And are they what type of AI do they use? Any hybrid version or? Thank you.
So it actually depends on the tool and what you need to have there. So for some of them, it's simply a Python function that's run and that the LLM orchestrator can just call when it needs it. But we also have, for some, where you need also some reasoning capabilities, for example, for comparing two pieces of text, for instance. For that type of things, we have then a specific AI agent that can be called by the orchestrator, but it really depends on the tool and what you want to be able to do there. So yeah, it's really dependent. For example, just for the search into the knowledge base, that's simply a search tool. You just have the LLM decide on what parameters should be used to make the search. But yeah, if you want more complex question to be answered, then you can have another layer of LLM in there.
Thank you very much. Thank you both. Great presentation.
Thank you very much. I'd like to present our next speaker, Lorenzo Gabrielli, who will be speaking about From Data to Dialogue, an AI chatbot for the Green Deal data space. Lorenzo is a data scientist at the European Commission Joint Research Centre. He specializes in computational social sciences and semantic interoperability for AI and policy support, and has over 15 years of experience in applying semantic and AI methods to enhance EU data interoperability and evidence-based policy making. Thank you very much.
Is that working? Theory should work.
Yes. So hopefully they are. There you go.
Okay. So thanks, Brooke, for the introduction. So it's a pleasure to be here to talk with you, and in particular to introduce our work, our joint work in the collaboration with SEMIC on the analysis of the Green Deal data space documentation. Well, so we recently discussed with colleagues across several DGs, including GIGIT and the SEMIC team, and we recognize how it's complex and challenging to retrieve information from PDF documents, and because those documents are not structured, so it's really complex to extract meaningful information. So our proposal in this presentation is to show to you how we improve the findability and usability of such textual content. And we propose a new approach that leverage on RAG and MCP tool. So a key added value of our approach is that we improve the data interoperability. Our workflow starts with the PDF documents, and first of all, using a tool provided by our infrastructure Zeta, we convert the text using a parser API, so we have the possibility to transform non-structured document into AI-ready information. And then before the ingestion of the text in our infrastructure, we clean and normalize the text using GPT-HRC. That is an infrastructure that we have at GRC that gives us the possibility to interact with several LLM models, including Llama, Mistral, and GPT-4. And another important building block of our infrastructure is Voila. That is a library that gives us the possibility to develop a user interface, and it helps also us to orchestrate all the elements of our workflow. So the idea behind this slide is to explain the process of transformation from raw PDF into AI-ready data. So we start with not with a structured document, a structured PDF document, and as we know, those documents are not ready for the ingestion. So we use an NLP library called Apache Tika Parser provided by our infrastructure SEDA, and we are able so to extract textual content and make it machine readable. Next, we have to clean a bit and normalize a bit the data, because as you know, in the PDF we have numbers, tables, and other noisy elements such as notes or page number that are not useful for us. So we create a dedicated GPT agency prompt that automatically clean the text, and we remove not relevant information, not relevant sections. And at the same time, we extracted also key metadata such as title, authors, publication years, and also the abstract. I would like to share with you some feedback about this activity that maybe might be useful for us. Normally, for such kind of activity, we use Llama for zero-shot classification or other activities, but in this case, for text cleaning, we switched to GPT-4 because we couldn't find a prompt that produces a satisfactory result with Llama. Well, at the end, we have a clean, structured, and enriched test corpus that is ready to be integrated in our SEDA infrastructure and became part of the SEDA knowledge layer. So traditional search system, even those based on semantic embedding, focus mainly on finding documents that are similar in meaning. So this is a good starting point, but it is not always enough when you need precision, context awareness, or structured control. So our idea of smarter search is to combine the semantic side, I mean capturing meaning through embeddings, and the symbolic side, which rely on structured filters similar to SQL query. So to manage this combination, we use MCP tool, which allow us to orchestrate both type of reasoning. I would like to emphasize that this part of the work is still evolving. At the moment, for those of you that is familiar with MCP, you know that each filter must be explicitly defined as a tool. So, for example, if you want to filter by author, but no tool has been defined for that field, the system cannot use it. So for this reason, we are working on a more general approach where the user question is matched with the underlying data model, and this would allow all metadata fields to be used flexibly. And so this integration will make the system truly intelligent. So let's now look in detail how our smart search works. So in traditional RAG-only system, the user question is transformed into an embedding vector that is essentially a numerical representation of the meaning of the text, and then is compared with the text chunk stored in the database, in the embedded database. So this approach captures the semantic similarity, but does not handle structural constraints such as dates, filter, or metadata conditions. So in our approach, the SEDA Smart Search API uses MCP to analyze the user question and align it with the schema defined in the search endpoint. Thanks to MCP, the system can interpret both the structure and the intent of the query. For example, in this case, recognizing when a temporal filter is required. So, and automatically reformat the request to match the endpoint specification. As you can see here, the user has to retrieve documents after 2023, so this request is translated into a specific element, in that case, date range starting from the last day of the 2023. So I would say that this process makes the interaction between the chatbot and the SEDA infrastructure both intelligent and semantically aware, combining the flexibility of the semantic search and the precision of structured querying. There are some key benefits of our approach. First of all, I would say that we improve the interoperability, making policy documents easier to find and reuse across systems. We also increase the speed because we allowing us to analyze large collection of documents much faster because SEDA is developed to analyze large corpus document. And thanks to the RAG approach, we achieve higher accuracy, providing contexts where responses rather than generic one. The system, I would say, is also high flexible, as the user can adjust the context and prompt to obtain more tailored insight. And finally, is this designed for scalability. So It can be applied to different domain document types while maintaining consistent performances. What about the future? Let's take a quick look of what we are planning next. In short, the goal is to make the whole system more interactive, flexible, and usable both for research and for policy support. So we are working on two main areas of improvements. The first one is the front end. So right now the chatbot responses are displayed in block, and so we would like to make this more dynamic by introducing the streaming, so that the responses appear gradually, just like a live conversation. We also want to add the possibility to download the documents retrieved by the MCP, so user can access the original sources directly and explore them in more detail, or maybe apply another procedure in Python, R, or Excel, I don't know. So, and the second area concerns the engine. So we want to give developers more flexibility in how MCP tools are designed, not just for document search, but also for aggregation, synthesis, and cross-document analysis. So finally, we plan to extend data ingestion to structured and tabular format, making the more complex database more accessible and easier to analyze. So this is an example of our working prototype. So we have an interface developed with Voila, as I mentioned before, and the user can specify the system prompt, change the various configuration and filters dedicated to the LLM setting, can select the model, can change the system prompt if needed, and also the citation prompt that is defined for when we decide to include the citation. These videos show how the systems work in practice. Unfortunately, we're planning to make a demo, but today the system is not available, it's under maintenance. So we have this video for you. As you can see here, we have a question: how will the Green Deal data space ensure the secure and transparent sharing of sensitive environmental and climate data among different stakeholders? In this box, you have the response and also the list of documents that are retrieved. So in green, you have the documents that are used in the summary, and in red, we mark the document that we does not consider in the summary. Maybe in the retrieval phase, the system recognizes that this document could be related to the question, but when we pass all this text to the LLM recognizes, according also with the question that receiving input, that the document does not provide the information needed for the summary, for provide the response. We have additional question. Unfortunately, we cannot play with this tool. It's a pity because it's also a multi-language tool, so we can also ask a question in different language and also translate it would be nice to translate the answers in maybe in Danish or other language. So I would say that the presentation is over. So if you have some question.
Thank you very much. Let's see if there is any question from the audience. Not at this stage, perhaps online.
There are some questions online. Okay, so the first one is, how do you deal with sensitive data that can't be sent through a chat GPT?
If I'm not wrong, due to the model are implemented inside, we manage sensitive data by default. So I don't know if I replied to the question.
I think so.
Yes.
May I ask a question, or is there any other question?
There's another question here. Can we hope to generate a shared machine-readable database of the documents instead of reading PDFs on each new project?
I'll make him read.
Yes. We start from the PDF document because unfortunately we are not able to access to the original information. So colleagues provide several documents for strategic analysis, and unfortunately the format was PDF. But in the past we worked with other data sources such as the GRC data catalog that is implemented in DigaDP. So we had an API to ingest the data and without the need to translate PDF documents into machine-readable format.
Thank you. There is a question from the audience.
No, it's not a question. It's just, I mean, to say that, I mean, if in fact we are limited with the data we have, but it's also a call for people. I mean, we know that SAGE project is here. So if we can have the source, data models, whatever they have, of course, the more information we get, the more efficient we'll be. So it's also a call for, I mean, people involved in data space, if they believe in that they also contacted us. They can contact us and share the information they find that would help us to have more accurate results. Of course, we're looking for whatever source is relevant.
Thank you very much. Okay, thank you very much, Lorenzo. Great presentation, nice demo. Let's move on with the next. Thank you very much, Lorenzo. Okay, our next speakers will talk about from data to decision, a skill-based labor market graph. I would like to welcome Leyla El Khamlichi here on stage. Leyla is a senior data scientist at UWV, the employee insurance agency in the Netherlands. She specializes in deep learning, language model, and graph-based analytics, focusing on semantics and ontological modeling of skills and occupation to support the labor market policymaking. Leyla, thank you. Welcome on stage.
Yes. I'm going to be a little bit more practical, and I think this is a topic that every country has to deal with, labor markets. It's quite challenging at the moment. I think different countries has a problem with filling different vacancies in occupation. And within the UWV, actually, we had a project started in 2019 where we actually wanted to develop an ontology where we could map actually skills towards education. One of the bigger problems that it is that the education part doesn't understand what is happening on the labor market, what kind of skills, what kind of occupations are changing over time. And to actually inform a little bit more the education parts, go through with skills. We actually developed a right business case to use graph databases, but also a bit of semantics together. And that's where I'm going to talk a bit about. So the project that calls CompetentNL, and actually what we discovered over time is that before in 2019 where we started, we had this problem that this education system in the Netherlands doesn't really are informed as what happening is in the labor market. And within Europe, we have already like ESCO, which is an European classification based on occupations and skills, where it's a little bit more detailed, but it's not really narrative to the Dutch labor market. So within that, the Ministry of Education, Culture, Science, and Social Affairs actually set up a budget where we could actually think about, okay, how can we make this standards, open standard that everyone can use within the Netherlands, but at the same time also two different organizations can come together, talk about semantics of different words, and that we can actually make statistics and understand what happened in the labor market, so policy leaders can make the right decision within the Dutch labor markets. So CompetentNL is actually like there's an occupations and are skill related to qualification systems, and it's actually a shared language to improve the labor market efficiency. And we launched actually 2 months ago when the data set is actually ready that everyone can use it. And it's a collaboration with Statistics of Netherlands, CBS, TNO, Beroepsonderwijs Bedrijfsleven. That's actually the organization when it comes to the education part. And of course, UWV. So actually why we chose graph databases and why we didn't choose like to set up everything in relation database. One of the things that we did is that we want to be an open standard and two different organizations needs to work together. So that means if our different skills are occurring more related within the labor market, somehow the two organizations needs to come together to understand what is happening. So because of that, and also the interoperability, and at the same time also being an open standard that everyone can use it, we chose as graph databases to take that as a basic. And instead of entities and rows that we have, we set it actually more in a graph. And I think if you put your data more in a graph, you can actually calculate very nice and interesting, insightful questions. So from data to graph is more like a technical foundation. So when we move to the graph, we actually shift simply storing the information of understanding the relationship between them. So within CompetentNL, we don't have just row and columns, but we have entities that are interconnected, occupations, skills, tasks, and knowledge areas together. So in the graph layer is actually the foundation where we capture how the elements are related to each another, and that's capturing them. Then if we move to the computational layer, that is where we start actually do the real work, calculating for me the similarity distance between occupation and understand like, hey, if a job seeker wants to come from one part to the other part, how could the path going? But the labor give actually also the algorithm a lot of power to explore certain questions that can help policy leaders to understand like what is happening within the labor markets. So within the ontology, it's, I think for people who understand, been dealing with an ontology in general, we have two different organizations. One is from an occupation perspective, and the other one is from education. So it took a lot of time actually to combine those two words together, understanding like, okay, this kind of word had to represent the education part, but at the same time, it also needs to represent the part of the occupation. So it took a little bit time when domain experts actually came together to put this whole taxonomy into it to understand like how can we share relationship and how we can combine that together so that an occupation is well represented from an education part, but also from a skills perspective. So if you come together, so for us, like this, the database that is filled in with occupations with skills. It has qualification structures. It will have also, we have in the Netherlands, we call it DUO, which is also another organization when it comes to education part, and it will be also filled in with courses and skills. So all there together, they're combined within relationship. And then actually what we did is we set up the CompetentNL data set towards the standard of ESCO and ISCO and ONET, which is also a classification system when it comes to occupations. And within different hybrid AI and bias models, we actually enrich the database because we all know that labor market is changing over time. So you cannot just not put one data set as an ontology and that's it. You need to have something that can actually understand what is happening, what kind of skills are coming. So we use vacancies and resumes of job seekers to actually understand what kind of skills are coming into the market and make from their statistics. From that we can combine from the CompetentNL API, where different organizations who's working with job matching or for ourselves, like understanding what is happening, we can make with that data set actually skills application and help employers, workers, and mediators to understand like how can we combine those data together. To give a better example, so within the data we have a node, which is an occupation, And within that occupation, it's labeled. So we have a task, a skill, knowledge elements, and working conditions. And for me as a data scientist, if the relationship does not have a property, then for me, it's not really interesting to actually calculate, especially distance between occupations. So within over time, actually also the domain experts actually put some properties on the relationship, which for me is very interesting actually to calculate. So within that, we actually combine two words together, because in the world of graph databases, we have research description framework, which is RDF, and we have label property graph, which is LPG. So we use RDF actually for linked open data, because we need to be an open standard. We want to be that everyone can access the data. We use it also for semantics, because two organizations came together understanding what kind of word can cover two words. And at the same time, it's also very good for data interoperability and federation queries. And for the LPG part, it's not really that accessible in the sense of that we can use it more for the weights and the properties. It's actually a little bit more stronger and faster if you want to make certain calculations. But I think that the power with LPG is actually that within the relationships that have different properties, you can make very nice calculations and actually help the policy leaders on certain topics. So how actually I, as a data scientist, put the semantic modeling into labor markets, where I can actually help in the term of the topic that we're using within the ministerial of lifelong learning policies, like what is the term for a job seeker or somebody that it's working, combining of the long learned policy, what kind of skills, what kind of occupation he or she can do in the future, and how can we make it more data driven and future oriented decision making. So within that is that policymakers at the moment within a certain topic are very increasingly focused on understanding the mismatch between the labored and also between the demand on available skills. So CompetentNL is actually model how skills and jobs and education are related to one another. And you can actually identify over certain calculation what are the missing skills across different sectors. And actually that's why the topic skills gap came above. What kind of skills do you have in common and what kind of skills do you miss? And if you don't miss those certain skills, what kind of courses or education part you need to take to make sure that you are more reliable within the labor market. To give an example, so we have two occupations, and in the middle we call that transferable skills. Those are actually the skills that are shared together. And so if you want to, do we have a pointer of this? Is there a pointer? No? Oh. Oh, no. Oh. No, it's back. Okay, well, no, never mind. So if you want to, like, let's say you are the occupation of the left side and you want to go to the other side, then, well, 80% of your skills are shared. So that means that you can easily go from one part to the other one. So we call it that occupation similarity, which means that we say like it's actually a green flag for you to go to the other one because you're just missing two skills. And then the thing is, the whole thing of CompetentNL is then actually come up together with all the relationship that is inside and all the properties that we have. Neo4j is actually helping us to calculate those distance and also actually to help job seekers, but also employers to think differently about the skill set. But if you want to go from from the other side to the other side, it's more possible because you don't miss the two skills. So this is a way how we actually try to understand what kind of skills or what kind of occupations are more closer to the other and one which are more further from the other. And if you take it to a graph, then you get this, and this is more zoomed in. But actually what you can do is really very nice. You can calculate from a certain start point and actually helping job seekers, but also employers, like, okay, you are searching for a certain skill set, or you have a certain skill set, and what kind of occupations are more in my neighborhood across the skills that I have. So if you take this for me is very interesting and very nice, but if you take it to a more something that's more understandable. So within that, actually, let's say that the purple one is the store manager, business manager, seniority sales, and actually that person wants to change their occupations based on different reasons. And then actually what I can do very nice with the data set is that I can actually calculate what kind of occupations are more closer to the skills that he has, but also certain occupations that are not close. And then the bigger question is like, what kind of courses or what kind of other skills I actually need to learn so I can still cover from one to the other one. So let's say the store manager has an interest in to be a precision instrument making. You see that he has just 15% of the skills that are related to one another. And then is the bigger question, what kind of other soft skills does he have? So maybe he can learn certain skills. And I think what's very nice if you put it in a graph where already there is a certain semantics, but where there is a graph and where you can actually weight with the properties and you make in certain skills, you can make them heavier, certain skills you can make them lighter, that actually make it for me as a data scientist to tell from a different perspective, like, okay, if this person wants to transfer from this sector to the other sector, maybe he doesn't have the certain skills, but he has other skills that he can make it so he can, that can be learnable. So we do use Triply, that's the software that we're using, what we use for linked open data and or for the semantics. But I think the power for us actually more is Neo4j when it comes to the calculation and visualization, because I can literally help actually policy leaders like, okay, what is a skills gap? When do we talk about skills gaps? How can we actually make sure that employers are thinking more in skills and not thinking in resumes and in diplomas and in other certain things, because we want to have a more skills-based labor market. So actually 2 words coming together where we combine them, and actually where we're also doing a lot of research on, and that's still that we are doing, is that we do have a semantic layer with the ontology from CompetentNL, and then actually with the calculations that I developed over time, we want to combine them together and actually make a kind of chatbot to see, or the chatbot is able, because of the semantics within the words, can actually give a better representation if a job seeker just asks the basic question, this is the job that I have currently, or this is the skills that I have, what kind of occupations can I do in the future, or what kind of occupations are more close by to the skills that I have. I think from my perspective that semantics helps a large language model to understand more certain words, because words are connected to one another, there is a relationship. And I think also that the skill computation, which is actually a machine learning model, if you combine those 2 together, I think that with the chatbots and understanding for someone as a job seeker or employer, what kind of skills are available for that person and what are the opportunities, it could be developing quite well. But that's something in the future I can talk more about. If you have any more questions, I say reach out. Thank you.
Thank you, Leyla. Hello, hello. Yes, thank you, Leyla. Great presentation, great tool. We do have some questions online.
Are there any questions on the floor? No.
Okay, let's see online.
So we've got some questions online for you. This is related to CompetentNL from the beginning of the CompetentNL, the beginning of your presentation. You were open to new relationships compared to existing ontologies. Did you try LLM assessment without the ontologies? And did you find new insights?
I think that's the complexity of not, like, of course you can say you can use a large language model to combine an ontology. But what we find over time, because we started when ChatGPT was not there yet, in 2019, and we discovered over time that we need to set up a kind of structure, and we don't have an ontology that's based on the Dutch labor markets. And we also saw that vacancies are actually very poor written, so the skills are not easy to find. The large language model that are not really well trained on labor markets and understanding the concept of what is a skill, and especially when it comes to soft skills, and especially Dutch, it's very difficult. So over that time, we actually find it that it's better to start that just domain experts are actually telling us like, okay, this is a skill, this is a soft skill, this is a hard skill. And we still, I think for certain skills, yes, you can use large language models, but when it comes to soft skills, because that's the main hardcore actually problem within within vacancies, that it's difficult to find, because those skills are very important when it comes to learnable, like if you want to learn something new. So I think you cannot do it without large language models. I think it's a combination of both.
Okay, thank you.
Yes, I have a question.
Yeah.
It's a great tool. And the question is, you mentioned several times policymaking.
Yeah.
It seems to be that that's the destination for this particular tool.
Yes.
But is there any other purpose or utilization, any
Yes.
other use case?
Yeah, sure. So policymakers, of course, is one of the topics, but also we are like I developed a calculation where I can actually also have a questions like, okay, as an employer, I want to think differently about skills. So I want to think different about talent, but I don't know how to do that. So that's also how the data set can be used. And also from a job seeker perspective, like coming in, because at UWV we pay a lot of taxes in the Netherlands, and you have certain benefits that you can apply for. But we want to make sure that every citizen in the Netherlands go back to the labor market. So also for them, like filling in, like, okay, this is the occupation that I have, what kind of different occupations that I can do? Because most of people, they think I can only do this in this sector because this is where I'm skilled. But if you think it from a more sector perspective, then you will see that your skills are very more broad in different sectors. So I think that you can use I definitely know that you can use the data set on different questions. But I think why I'm just heading on the policy leaders is that because policy leaders are struggling within the labor market, like how can we make sure that this employer thinks different, like think more in skills perspective, or the job seeker thinks more like in skills as well. It takes a lot of question that it has, and based on that, policy makers should make the right policy so we can push the right people to the right place in the future.
I have a follow-up question, but first let's see if there is any other question.
We do. We've got lots coming up. Regarding ESCO, how could this be improved to be useful in the Netherlands?
I think the problem with ESCO is that ESCO is very, very, or it's like too high level, like high over, or it's actually detail orientated. And the problem with, I think that ESCO should actually have more in related that understanding from each country how the skills are related. So what I mean with that is that if you have an ontology that's based on whole Europe, it's not possible to detail very well for which country the skills are obligated to. So I think that ESCO can actually learn from how the Dutch labor market or the Dutch CompetentNL is actually be set up, and then from there on to see like do we have to be that more detail orientated, yes or no? I think in that way.
We have other ones. Do you plan to collaborate on similar projects with other Dutch universities?
Yes, I'm currently working a lot with Universiteit van Leiden, where we want to understand the biases within the labor market. So HR applications are using nowadays a lot of large language models to source, but also to rank different candidates. And we want to understand the biases within that. So yes, that's something that we are doing. And also in the future, are there universities to reach out? Yes, for sure. But that's why it's an open standard.
And how about cross-country?
Also in the future, but that's something that I don't have a very clear answer to but I think that's also in the future. But for now, we just focus on the Netherlands. And I think that I set up a data science group within Public Employed Services within Europe. And I think that we want to actually tell ESCO more like, okay, if we could do it a bit like the Netherlands, that everyone has his own ontology, maybe we can combine that together and be the new ESCO in a way, because then you are more detail-oriented towards a country. So yeah, maybe in the future, yes.
Do you also use the European qualifications framework?
I think, I'm not sure. I don't know. I think, I'm not sure about that to give that a clear answer on it. No, I'm sorry. I'm not sure. I think, well, yeah, I don't know.
I have a question, and I don't know if we need to move on, but this is, I think, it feels important to me, but it's regarding privacy.
Yeah.
So there's always this conversation around AI that at the end of the day, we can't really trust. The more data we have, the less privacy we will have.
Yeah.
We will, even the personalized data are not necessarily secure enough. Now you're putting tons of information in the system, you are cross-relating skills. What is the risk that privacy is breached?
Well, we don't use personal data, so we don't use really like some of the topics from the resume of the data. We only use the part where job seekers are actually expressing their soft skills, because we had this problem of finding soft skills within vacancies. So we don't use personal data at all. I just think that what we have to be unsure about, what we have to keep in mind is that there are certain skills that are more male-related or more women-related. So when you use a large language model or ChatGPT or whatever you want to name it, and you want to, like we say, rank on certain skills and you use a certain gender, then yes, it will have some biases and it will have definitely a certain outcome that it can be not okay, actually. But I think if you just keep it on the skills and keep them like average, then I think you should be okay.
That poses the question of bias, but perhaps we give it for the panel.
Yeah.
Right?
That's another topic.
Okay.
Okay, thank you so much.
Thank you.
That was a very good presentation. Thank you. Our next presentation is going to be about AI-generated interoperable legal term glossary. And this is going to be presented by Heinz Schröter. So please come up. So Hans is a data scientist at PwC. He is an AI specialist focusing on generative AI, including RAG, fine-tuning, agent architectures, and applied analytics. Hans today will present Alexa, an initiative by the German Ministry of Finance to create an interoperable legal term glossary. Thank you so much.
Yes, so we have been working in the last couple of months at the question on how to create an interoperable data exchange system between federal states, public authorities, if the answer to the question, how many data fields for income, for example, do we have in Germany, is multiple dozens. So that's actually the crucial point. That's actually the challenge we have been working on. And what does it take to build a system where we can exchange data that is interoperable and where we have a seamless integration between different public authorities. I'm Hannes, and I'm presenting here the project that we jointly developed together with the Federal Ministry of Finance in Germany. And in the next couple of minutes, I will give a short introduction into the approach we have implemented and why it circulates around legal terms and definition when we want to exchange data. So this is the context of the project. It's part of the Digital Check program in Germany, which has been mandatory in Germany since 2023. And we have been focusing on 2 of these 5 goals. The second one promote data reutilization and standardization, and the fifth one, facilitate automation. So when we come back to the example, why data exchange between two public authorities is difficult. On the left-hand side here, we have authority A, and authority A collects income data for tax processes. And then we have authority B on the right side, and authority B collects income data for social programs and benefits. And as you can see in the structure below, the data fields are different. And this is hindering actually both authorities from exchanging data. At this point, one could argue, okay, then we implement interoperability not on a data object level, but on a, let's say, on a data field level. But the actual root cause for this problem goes much deeper. The important part here is the things that are written like in bold. So the underlying problem is that both authorities use different legal definitions. And even if semantically both terms might, in this case, even be similar, they have on a very precise legal nuance level, they have different legal definitions, and therefore they have different representations and mean something different. And we can use, or we made use of one circumstance that we have. So the authorities, they are allowed to collect data that can be derived from a precise legal basis. What that means is that actually the data landscape, the public data landscape, is a reflection mirroring the legal term landscape. And that also means that ambiguity in the legal terms and definitions, they directly translate into ambiguity in the data space. So that led us to the conclusion that in order to facilitate data exchange, we need to know what we are talking actually about. And we need to know what a data field means. We need to know what the definition behind is. Having that said, for us, that meant that we need a unified and consistent reference framework that can be used as a unique identifier for data fields. So we need a common denominator for data fields, and the basis for that are legal definitions. So we didn't say, okay, we have incomes multiple times. That's a problem, that's totally fine. We have it in a social domain, in various legal domains, and that's not a problem. The problem arises when the data fields are defined just by the legal term. And therefore, we need somehow a reference, a unified reference framework that serves as a unique identifier. Why is that a problem, or why doesn't that exist? So in Germany we have 1,700 laws, we have 2,800 ordinances that makes up a combined sum of almost 100,000 paragraphs. So manually creating such a data structure or maintaining it is just impossible. And that's even less impossible. I mean, that's yeah, that's not even legit to say, but it's even less impossible considering the fact that this is not a static field, it's consistently evolving. So just with the course of time, everything you build manually gets outdated. And this is exactly the problem where we built a GenAI solution for. So the solution we built consists of three main parts. It's, we use GenAI to structure and analyze law books, identify dependencies and the context of legal terms. We use GenAI to create a unified and transparent legal term glossary, let's say it like that provides a transparent overview about existing definitions and terms. And then in the following and subsequent step, we map the data fields to those legal definitions and use the legal definitions as a unified reference framework. So with respect to the demo that we are that I'm going to show about in a couple of minutes, it consists of 2 parts that we also like to think of separately. So the first part is really the Gen AI solution, where we use Gen AI to process law books to transfer it into a knowledge graph that represents legal terms, their dependencies and definitions. And then the second one is one use case for such a data structure, which is the tool Alexa. And Alexa is a text editor that can be used in the legal bill drafting process, and it directly recommends existing definitions, provides transparent overviews, and we can propose to the user the reusage of a definition with just a couple of clicks. From a technical perspective, we had quite a challenging setting. So there is no legal term list. Nobody could tell us, okay, you have here a list of those 20,000 legal terms, try to find the definitions for that. And that might seem a little bit surprising at the beginning because it's so easy to think of examples. When we think about these problems, we always think about examples. But coming up with them from a semantic perspective, really identifying what characterizes legal terms and when they can be, let's say, aggregated, when to a more abstract term, how the relationship are, this becomes really, really challenging. And also when we look at the requirements, we have high accuracy because we are in legal domain, and we need to be very precise on the data structure that we produce. We have high consistency. We need to be very, very accurate in when it comes to references, to legal citations that we just fit and achieve the expectation from legal users. We have reproducibility. So if we run it multiple times, that results are the same. And we have scalability so that the solution works on every law books, basically, and is not overfitted to just a certain subset of it. To those of you familiar with LLMs, I would say this is probably not the strength of the technology, so that for us really required to have come up with a good architecture on how we really produce a data structure that is consistent and can meet up with those requirements, and only use Gen AI when it's really, really necessary. So our pipeline basically consists of 2 main modules. The input of the pipeline is our law books as they are. We just put them into the pipeline, and then we have the first component that basically creates the legal term glossary, identifies the dependencies and the definitions, and constructs a knowledge graph. And then we have the second one, which is called modularization. That basically means that we break down a definition into its elementary parts, a little bit like Lego building blocks, because those parts are then the bridge to the mapping for data fields. So the outcome of the Gen AI solution is basically a knowledge structure, a knowledge graph that has a wide range of use cases. So the one in the middle I was already mentioning in the beginning. For us, it's a requirement and a necessary dependency to have it as a unified reference framework for data field mapping and data exchange. Then we have it for legal assistance as well as the tool Alexa and many more. So here you can see a picture of the knowledge graph. And I will just switch to the demo. I hope that everything works now. Okay, we can switch the screens.
Should take a moment.
Perfect. So this is basically now the tool Alexa. We can, it's a front end with a text editor, is directed, or the target group are the ones who actually are crafting the legal bills. We can click here on the graph visualization. And this is now, let's say, a demo subset, just illustrating how the data structure and the graph looks like, right? We have different node types. It's German, so I won't go too much into detail, but we can basically see how those legal terms are connected with each other. We can run cluster analysis to identify also semantic concepts. But in our case, it's the most important feature here is that we have the legal terms, that we have all existing definitions from the law corpus, and we have the basic building blocks, these legal parts that are then used for a mapping to the data space. So here, when drafting a new law, we just put in whatever we want. For example, the income, it works in German. So I put it in brackets. It automatically detects the legal term that we have in the database. We see here now, I think more like 12, 13 definitions of the term income. We can click on them. We have directly the data source. So the legal reference, and we have the existing definitions. We can also see whether data is available or not. We can navigate through it, select the definition that we want to use, and insert it just with a click. And this way, we offer a system or a small tool that already within the process of crafting a bill provides full transparency to the user what definitions exist. This is nothing, no glossary exists at the moment like that. So we provide the information transparently what definitions exist, what data exists, and also what the elementary building blocks of the definitions are. I will show that for the data also in a second, and the industry registration number. And on this way, they see already, okay, for this specific logic or this legal, let's say, entity, we already have data. We have data available. We can access it. And in a subsequent process, this is also relevant because all the administrative processes, they don't need to capture and gather those data points from scratch. So we can just increase the reusage of the resources that we already have. So then we can switch back to the presentation. So for us, what does this solution enable? One thing is transparency. So it provides legislative drafters with the access to a comprehensive database that presents legal terms, their definitions, and components in a clear and transparent manner. We, as I said, improve reusability of definitions and of data. It's automated, so it's a fully automated AI solution, which always stays up to date. And as a result, Alexa dynamically adapts to changes, legal conditions, ensures that it always reflects the latest updates, and at the same time it facilitates data reuse, contributes to the digital readiness of legislation. So to sum it up, Alexa is designed to support the law drafting process by harmonizing both legal terminology and the data landscape. It represents one potential use case for a knowledge graph that we have shown, among others. So if you have any ideas, if you're interested, then please reach out.
Johannes, thank you. I don't know where to stand in order to make sure that people look at you and the camera look at you. We'll try it here. We'll see how it works. Great presentation. Let's see, and great tool. Let's see if there is any question from the audience here. No? Yes, there is a question from the lady on the third row.
Thank you very much for the presentation. And sorry, maybe I messed up, but who are the end user of this AI assistant?
The people who actually, I don't know what the English word is, the people who actually draft the laws. So the people who write laws.
Okay, okay.
From the end tool, right? So the target group or the use case for the knowledge graph with respect to the data mapping is totally different. But from the tool, it's for the people who write actually the laws.
And do you also plan to implement maybe AI agent for law generation based on this tool or no?
At the moment, it's not planned, but let's see.
Okay, thank you.
Just leading on for this question, how confident do you find those end users in using this tool in their end work? Is there a big uptake of this work?
Yeah, I mean, confident is difficult to grasp. At the end of the day, it's providing information that is not there at the moment. So it's not like on a critical path where you say, okay, like you can break now a lot of things if you show a definition that's not there. It's just an additional support for the user. So having that in mind, the acceptance is good.
Thank you. That's great. I have a couple of questions, actually. Super interesting. I love the tool. How do you only use for German laws? Do you also connect to European laws? You were saying an impossible task in Germany, but if you scale it up, there's a even impossible task for everyone else. So. Do you scale it? Is it only for German laws? Or?
No. So the solution from an architectural and conceptual perspective is developed fully generic to be adaptable also by other countries. So yes, in the POC we only focus on German law.
And how open are you? You say, okay, it's scalable. Everybody can use it. How much?
It's on open code.
It's on open code.
It's
Perfect.
public,
Fantastic.
right? So everybody could basically download it. However, I mean, it's a POC state, and obviously one would need to do like some adjustment, like then for the specific law logic, let's say it like that, of the respective country. But we emphasize to develop a solution that, from an architecture perspective, is generic and adaptable and scalable to other domains as well.
Are you also envisaging other type of use cases? You were mentioning only for lawmakers, but is there anything else that have you thought that could be useful for?
Yeah, I mean, we made, I was just looking at my colleagues, but I guess they are in the other workshops. We made a list. So she's Kathleen, she was the project manager.
Hello, Kathleen.
Hi. Well,
good to have you here on stage.
Yeah, okay. First, when we built up Alexa, it was built up for data matching, for the once-only principle. That was the main goal at the first step. And then we found out with user experience, even the legislative drafters said us, oh, it's nice to know which legal terms we have that help us a little bit more than we doesn't want to know in the first step which legal term consists or is modelized or it's modeled in which data field. So with the user experience says, oh, we want to need the legal drafting, not the data matching. So it was an experience. So mainly it's more if we build it up more for to build administrative services for the once-only principle we heard about in the morning.
Yeah, it sounds like an evolution. Great, like every great product should always have new use cases coming and evolving.
Yeah, because in the another session we want to talk about how we could match data. It's a quite big problem in Germany because of semantic interoperability we doesn't find. So we built big IT architectures we can use because less semantic interoperability. So it's a huge project.
Thank you.
Problem.
Yep. I have one final question, if we have a minute. So you were talking about for specific use cases or specific processes, you were not particularly happy with Gen AI per se. So are you using any other forms of AI? Similar question that I asked Leyla. Is it any hybrid forms? Are you specifically using Gen AI? Any symbolic AI neural networks?
No, so we don't train like our own models for anything. So the parts that are AI are LLM based, and I think it's totally fine because they have just an incredible semantic understanding. And also remember that we don't have like any initial benchmarking data because this is a data structure that doesn't exist. So it's also hard to train something specifically like for this problem that you would require for traditional AI. We just needed to be very careful when to use it and how to use it and do it like very dosed.
Thank you very much.
Thank
Ladies
you.
and gentlemen, Kathleen and Hannes, thank you very much for your presentation.
Thank you very much. Now we're having a break, so there's been a fantastic first half to the session. Thank you very much for all your engagement. 20-minute break, so please be back into the room at 4:30. Thank you, everybody.
Thank you.
Okay, so moving on, we are going to be now hearing about semantic interoperability in the context of LLMs for EU. I'd like to welcome Penny Labropoulou to the podium. Penny is a principal applications researcher at Athena RSILSP Research Center for the Institute of Language and Speech Processing. She specializes in language resource infrastructures, leading metadata modeling and semantic interoperability in the European language data space and LLMS for EU. Penny also co-chairs the W3C Linguistic Data for Language Technologies Community Group. Thank you, Penny.
Thank you for this invitation. This presentation will be a little bit different from the previous ones that you heard because it's going to be mostly about plans and futures activities. So I'm going to start with an overview of the project and then zoom into interoperability and semantics aspects, both in the project and mainly in the LLMs for EU catalog. At a glance, what I'm presenting today is the project Large Language Models for the European Union. It's a 36 months project. It started back in the 1st of March, and it's still in the beginning. We're still at the requirements and specifications phase, so this is why I'm saying that most of my part will be about the activities that are planned in this project. It's funded by the European Commission, digital project, more specifically the language one, and the project coordinator is ALT-EDIC. That's the Alliance for Language Technologies EDIC that was officially created 1 year ago for the promotion of language technologies. We have a rather large consortium of 67 partners working in 19 countries, multiple languages spoken, different activities, different fields of expertise, research, academia, public organizations, companies, working in different areas like the development or use of LLMs, Euro-HPC centers, etc. You can imagine the challenge already to speak a common language between us. The objective of the project is to address the issue of language disappearance in the digital age in a region where around 80 languages exist. Obviously, this is something that the plan is to use AI, activities around AI to tackle these issues. We're in Europe, European values, etc. So the focus of the project is to ensure European data sovereignty, create market opportunities for European AI players, and enhance the competitiveness of European industries in order to leverage cultural and linguistic diversity. Obviously, the promotion, the recommendation of using generative AI is in order to break down communication barriers and facilitate exchange across Europe. Another important activity that is undertaken in this project is the development of AI applications in key sectors aligned with the EU's strategic objectives. 5 sectors have been identified: energy, tourism, telecommunications, public services, and science. You can see on the slide the expected benefits from integrating AI into these sectors. Taking a look at the action lines where LLMs for EU is going to go into. First of all, it intends to establish a central platform for European language data, which will be first populated with the high-quality data sets that will be collected throughout the project. With respect to language models, there are 3 action lines. One is to collect and document existing open source models and use them in fine-tuning for selected use cases in the 5 aforementioned sectors, addressing real stakeholders' needs. It's going also to promote the development of new language models coordinating access to Euro HPC computers for the companies that will be involved, engaged in the development of these new models. Very important, it will provide methodologies for the evaluations of large language models, for the certification and normalization of these methodologies, addressing, among other, discrimination and bias issues. Overall, it intends to develop an ecosystem for AI, that is, to develop a startup incubator for businesses, promoting links between industry and research, and acting as a key player in the European Coordinated Plan on AI, strengthening mainly the language technology community. Let's zoom into the way LLMs for EU is going to address interoperability requirements, interoperability needs. First of all, to develop and fine-tune open source LLMs, it's important not only to find data sets that can be used for fine-tuning these models, but as well as generic LLMs, it's important to also prepare this data, convert them into the appropriate formats, into the appropriate forms that can be used for training LLMs and fine-tuning LLMs. Evaluation, very important, again, interoperability. We need a common ground for comparing and contrasting models. In order to do that, we need standardized data, standardized methods, standardized metrics, and of course, we also need a standardized description of these results, of the methods and the tools, etc. The plan is to develop a comprehensive inventory, as I said before, for LLMs and related data resources. So in order to have them, to make them findable, accessible, and reusable, it's important that we have interoperability in their description and their representation. A common semantic model, a common metadata model for their description. And all these can be consolidated in a data infrastructure that takes into account these common metadata models, data formats, API interfaces, workflows for the data preparation that I said before, allowing exchange and aggregation of language data and feeding them into the training process. Just to have a quick look to understand the challenges that we're faced with, these are a subset of the use cases that are now being defined in these 5 sectors by the 67 partners that I mentioned. Different tasks like scientific writing and communication, knowledge extraction, data privacy and processing, and of course, different types of data sets in different forms, in different formats that need to be somehow normalized and used in the various use cases, in various modalities, not just text, but also audio, sound, speech, and video and image. One of the main instruments that are going to be used in this data infrastructure is the LLMs for EU catalog of data sets and models. In order to cater to serve for this semantic interoperability, we have decided to use a common metadata model. This is the language DCAT AP. The language DCAT AP profile has been conceived, designed, and implemented, first of all, in the framework of the language data space. That's one of the common European data spaces. And it's conceived as actually an application profile, both of DCAT AP and ML DCAT AP that was presented in the previous, before the break. Where we're using customizing and extending properties from DCAT AP for data and from ML-DCAT AP for models. We're collaborating on this with the SEMIC team. And we're also reusing another ontology that has been there for language data and language technologies for a long time, if I remember well, since 1996. And it's used in language resources and language technologies infrastructures. That's the MetaShare. And we use it for the concepts that are specific to our own data. As I said before, the language DCAT AP has started in the language data space, where the focus was on findability and accessibility. For LLMs for EU, the parameter of usability has also become very prominent, and we're extending it in this project. We're currently on version 09.5, a work in progress, and we're covering properties, descriptive properties for datasets. Under datasets, we have two subclasses, corpora, that is collection of monolingual, multilingual, raw, and annotated datasets in any modality, as I said before, text, audio, video, and image, and obviously also multimodal data. We also distinguish as a different subtype of dataset, lexical conceptual resources, that is terminologies, glossaries, ontologies, thesauri, etc. Models are also described, including LLMs and multimodal models. And finally, language technology tools and services that are processing the various data. Language DCAT AP comes with a number of tools already for the provision of metadata descriptions, validation with shackle rules. The profile itself is implemented in RDF, Turtle. And we also have editing tools that are integrated in the language data space connector. For those that are not familiar with data spaces, a connector is the main component through which all data space transactions, exchange, transfer of data sets are made. And it aggregates functionalities both for providers and consumers. One very important action line for us that we're working on for the metadata modeling is that of mappings and converters with other used metadata models, so that we can import or export metadata descriptions from other infrastructures. As I said before, we're working on this with a SEMIC team for the ML-DCAT AP. We had discussions about this with the Croissant team, and also European Language Grid and Clarin, for those that not know them, are very popular infrastructures for language technology and language data. Before this presentation, we had a very small experiment to see just how it works, using ChatGPT just to see how we could do the mappings between language DCAT AP and DCAT AP and ML-DCAT AP. We didn't expect anything spectacular because obviously we have based our own profile on these two, but we just wanted to see how it works. The results were, as we expected, very normal. It found full and partial matches, taking into account also the optionality level feature. And the idea is that we plan to try and use it also for the mappings with the other metadata models that are much richer, more complicated. And for this, we want to use not only labels, as we did with this experiment, but also work on definitions, see how easily it can find similar properties that use different labels but have similar definitions, similar usage nodes. Now, the LLMs for EU catalog is also something that we're going to base on the LDS, the language data space implementation. We're going to use it already for the MVP that we're going to launch in the next few months. And For discovery, okay, obviously traditional search. We can also use some a little bit more semantics using synonyms and hypernyms, etc., for the free text queries. But we think it's most interesting is to see how we can use AI in our domain, in the metadata and data domain, for the discovery. So one of the future versions of the catalog will have an AI-enabled discovery using a chat-style agent that will provide task-oriented guidance using RAG over catalogs, metadata, and documentation. The idea is that in this way we can broaden the search space to find also data and models that are hosted in related infrastructures like Hugging Face, other common European data spaces, the AI on demand, etc. Obviously, in full respect of their own sharing policies, going into agreements with them if needed, and of course using, to the extent possible, interoperable APIs. Most important, what we think this AI agent will bring into the discovery workflow is the enrichment of results, comparing and contrasting. Instead of having results of snippets from the from the results, you can have a summary of the of the similarities and the contrasts between data and models that are depending on your query. You can have recommendations and justifications on where these recommendations come from, and obviously guidance for further querying, potentially also some instructions on how to deploy and use the models or how to prepare the data for the AI applications. For this, obviously, the RAG classic workflow is going to be used, detecting the user intent from their query, reformulating it in a traditional search mechanism or using RAG-based approaches, searching these in the metadata description and the related documentation, and by that I mean any user manuals, instructions, scientific articles that have been published about the data set or the model, continuous improvements of these queries through cycles of showing the results and getting user feedback that feeds into the new query and results. But as I said, these are all for the future, and I hope in the next SEMIC conference or another conference, we'll be able to show you something from these plans. And with this, I conclude. Thank you.
Thank you very much for your presentation. I need to check. Ooh, it's reduced. The size of the room is reduced. Any question from the audience? I do not see any hands. Any question from online, from Slido? No. I do have a couple of questions for you. So first of all, first and foremost, congratulations on the project. I mean, it's relatively big and interesting. We'll see how it develops. So you were saying, so you will use a lot of data in order to so.
That's the plan. Yes.
I struggle still to understand where this data is coming from. I don't know how to phrase this one differently. So where are you planning to get the data in order to?
The partners that are involved in the use cases are already inventorizing the data sets that they want and the data sets that they already have and they can reuse. Obviously, not all of them will be, not all of the use cases have already found some data sets. The idea of using also synthetic data is on the table. Mm-hmm.
That creates the problem of biases, though, because obviously creating synthetic data. So how you plan, especially if you use a lot of synthetic data, how you planning to?
I don't think the plan is to use a lot of synthetic data. Okay. I think this is going to be like the last resort. And obviously, this is also going to be in the metadata description so that you know that this model has been used, has been trained or has been fine-tuned on this data set and that data set with these properties and has been used on synthetic data, etc., so that you can, the point, in my opinion, is not just avoiding synthetic data or avoiding biased data. They're always going to be there. It's not easy to minimize them. You at least need to know how they have been created so that you can judge on their quality and see how you can use them.
Very good. And so your goal is to create new models.
The goal is to collect and describe existing models and fine-tune also in the specific use cases where there are no other solutions, yes, creation of new models as well. But mostly it's fine-tuning existing generic models into the domains and the use cases that will be selected.
And I suppose you're going to select the open source model, preferably European,
yes, preferably.
Mistral, right?
Depends, I suppose, on the use case and the domain, which one can give you the performance. I'm pretty sure there will be cases of testing, seeing the performance and going through them.
Are you planning to use other open source model, DeepSeek or?
I think so, yes. Okay. I can't say because I'm not involved right now in the definition of the use cases. This is why I had the first acknowledgement from my colleagues that are working in these work packages. But I think, yes, they will try to use other models as well. And don't forget, there are other projects right now that are creating new open source models as well.
Yes, very good. Mm-hmm. Do we have a question? Okay. Thank you very much for your presentation. Very good. Thank
you.
Our next speaker is going to talk about language models and semantics from the private sector perspective, so great. The presenter is Dennis Dieffenbach. So welcome on stage. Dennis is the CEO of the QA company. He specializes in RDF and semantic web technologies, applying them to real-world use cases for organizations such as DG Radio and DG Com. He's a researcher in the question answering over knowledge graph, has previously worked at IBM and SAP, and has published extensively in leading semantic and web venues. So welcome, Dennis. The floor is yours.
Thank you very much to everyone that you made it until the last part of the conference. I hope I can share some cool things with you. For the people, thank you very much. Okay, so the thesis that I want basically to underline in my talk is that semantic data and language models are fundamentally orthogonal technologies. And I basically would like to argue that one will not replace the other, but one will basically benefit from the other. So let's maybe go back to what basically these two technologies fundamentally are. For me, semantic technologies are basically technologies that are very well adapted to store structured data. And this data is generally data where there is a very flexible schema, where we would like to encode data in a very interoperable way. That's also the main topic of today. And generally also in a multilingual setting. So when you have use cases like this, semantic web data is perfect. On the other hand, we have the world of language models, so of small language models, or also of large language models. And language models are in general very good at generating and understanding language. So language models will not replace semantic web technologies because basically you cannot store structured data into language models. And on the other hand, we will not be able to replace language models with semantic web technologies. So they are two very different technological stacks, and they are relatively transversal. And the question is, where is the meeting point and where basically one can profit from the other? So it's a question of synergies, and I would say there are mainly two parts. So you have the knowledge graph in the center, and then you would like to use language models either to construct this knowledge graph or to consume the knowledge graph. So on the first part, to construct knowledge graphs, we have different tasks. So we have something like ontology design. We saw a small example today by Edward Curry that was saying, oh, I put in ChatGPT a prompt to basically create a shackle shape. This would be a typical task where basically language model can support us in ontology design. But you can also, of course, do knowledge ontology creation. There is also the part of data transformation. Leyla mentioned it shortly. So basically you have some unstructured data or some semi-structured data and you want to convert it in RDF data. So language models are pretty good at doing this. And then there is also the part of basically RDFizing textual data, something like text to graph. We had also an example in Alexa where basically you have legislation and you would like to convert this into RDF data. This part, so basically the use of large language models to construct knowledge graphs is not my specialty. I would like to focus more on the second part where basically you already have a given knowledge graph and you would like to consume it and you would like to use language models to consume this data better. And I will try to show this on 3 concrete examples. Before we have an example, we have the 3 examples. Basically, we need a graph. And the example that I will use is basically the EU knowledge graph. The EU knowledge graph looks more or less like this. It's an open knowledge graph. It is available under linkedopendata.eu. It is hosted in a wiki base, so it contains information about institutions of the European Union, country capitals, and ministries from the European Commission. If we take, for example, this node, DG Connect, this is the representation of it in a structured way. So we have the node Q83 of the Directorate General for Communication. We know how it is expressed in different languages, mostly European ones. And then we have properties like it is a subclass of the European Commission. It is the director manager. The director manager is Roberto Viola. And of course, it's a graph, so we can jump from node to node and explore this graph. So this is the use case that we are working a lot with. It's a very small, it is a very big graph. It has 1 billion edges, and it is mostly encoding projects that are financed by the European Union in the framework of cohesion policy. So I will show you an example just that you understand then the subsequent part. This is a project in France. We have how it is called in the different languages. It is basically it's placed in Isère. It's a cohesion project. It's placed in France. The EU paid €500,000, and the total budget was 1.3 million euro. So we start with this graph, and now I would like to present you 3 tasks where basically language model can help us consume this data. The first task is basically linking knowledge graphs. It's something very common. It exists since years in the field of semantic web. And basically the task is that you have 2 knowledge graphs. It can be also a taxonomy and a knowledge graph. And basically you want to align vocabularies between the 2. And the semantic web data is basically used to represent this vocabulary or these terms. But in fact, they are generally encoded slightly different, with different strings, with different descriptions, and sometimes they are ambiguous. And so this is a perfect use case for knowledge graphs, for language models, because language models are very good at basically understanding these representations, and so to decide if 2 things are the same thing or not. And this is done, for example, by the publication office. So here we have 133 vocabularies, and these vocabularies are generally about a specific topic, and we want to match them basically to the EU knowledge graph. It's a typical problem of interoperability. You have 2 vocabularies, you want to align them because you basically want to reuse data and connect data. And what we can do is basically we ingest one of the vocabulary. This is a vocabulary about, I forgot. And there are terms like class struggle, drug addiction, social problem, tourism statistic, prescription drug abuse. So it's typical term that the publication office publishes and that you want now to relink in the EU knowledge graph. And in this case, we have different alternatives. So for example, we have classical class struggle, concept in political and social science. We have a 2020 film that is called like this. There is an episode of The King of the Queens, whatever, and there is a scientific article. So in this case, basically, what does the language model do? It's not a large language model, it's a very small language model, but basically, it is basically checking the different possible combination, and it is defining a score, and this for the whole 66 terms. You need very small training data to do this, and then you scale it, and you can do it for the 136 vocabularies. So it's very nice use cases to basically scale out with large language model this task of entity linking. This was the demo. The second task that I would like to show you is about entity linking. This is also a very traditional task in the field of semantic web technologies. In this case, you have a text, and you have a knowledge graph, and you would like to find in the text dimension of this knowledge graph. For this, you need already a slightly bigger language model. And in this case, the example that I brought is relatively simple. So, okay. So we have this text. Welcome to the EU knowledge graph. This is a graph containing structured information about the European Union and so on. And basically, we link it to the corresponding entity. So this is a node in the graph. This is the node of the European Union. This is the node of the European Parliament. This is the node of institutions of the European Union. And the task it looks a bit trivial, but in fact, it is not so trivial because, again, there are many concepts that are called countries, the world, Italy, and so on. So you have to identify the right span, and you have to link it correctly. And per se, it's an old task, but the nice thing with the advancements of language models is that this task becomes much more accurate. And also, generally, entity linkers were bounded to a knowledge graph. So you build a knowledge graph, then you build an entity linker. But what we can do now is that we can basically come up with a graph. You take your RDF graph, you load it, and then we can basically create an entity linker on demand, so that you can basically have entity linking tailored to your specific knowledge graph nearly on the fly. And the third task that I wanted to bring is basically text to Sparkle. The idea is you have a knowledge graph, and the classical way to access a knowledge graph is Sparkle. And in this case, you want to basically not write a Sparkle query yourself, but you would like to do use a natural language request. And this is one type of graph reg, I would say, because in this case, the language model, for this you need a large language model. So we are a company that is specialized in basically always combining language models and data, and we are generally doing this in a sovereign setting. So you want not to have data leaks. So we are trying only to use on-premise language models that either we fine-tune or not. And in this case, it is kind of graph reg because we want basically to show part of the graph to the language model. And a request could be, give me the number of projects by fund in Malta. So there is some initial reasoning. Basically, here saying, projects are cohesion projects. They are identified by this URL. Malta is another entity, is identified by Q32. Projects are connected to Malta via the property with path expansion. And then basically at the end, we have this generated Sparkle query that we can execute. And this then gives us basically back the fund with the number of projects that are in this fund. Can you give me back the number of projects in Malta by fund together with their RDF label and ordered in descendant order. Let's try. So the point here, I wanted it, okay, now the problem is there is a label in different languages, so he repeated it. So with their English RDF label, let's try again. So the point here is that okay, you have a language model, but you have a very specific knowledge graph. So basically, the language model has to adapt to the knowledge graph. So he has really to see the knowledge graph. And then he also has to see, so he added here now the filter lang en. And here, basically, now we have the different funds. Yeah, so there are multiple things that need to happen here. So basically, from this request, you have to recognize entities, then you have to know how these entities are connected to each other in the graph, and then basically you have to generate this request. And the other difficult thing is that language models are very good in zero-shot, in the sense that they give you back a Sparkle query, but maybe it is the wrong Sparkle query. But this is not something that you can use in production. You want something reliable. So the trick here is to have basically always a reliable Sparkle query that gives back the representation of your natural language question. Okay, so that was my talk. I hope that I brought the message. The message is knowledge graphs and large language models are orthogonal technologies. It's not that one will replace the other because they are very different in problems they are solving. Language models can significantly help basically deploying semantic web technologies. And I gave 3 concrete examples. Once you have a knowledge graph, which are linking, entity linking, and text to Sparkle. If you have any question, of course, you can ask now. And otherwise, we are the blue guys sitting also somewhere outside, so do not hesitate. Thank you very much.
Thank you, Dennis. Obviously, we are running out of time before the panel, but I do have a couple of questions. Maybe I'll ask one. Let's start with that one. So you show a couple of examples, 3 in particular. The first one had some reliability score on the output, but the third one showed just links. But I couldn't figure out, maybe it was too fast, I couldn't figure it out if it was any reliability score. How do I understand or okay, the validity of the output?
Yeah, I would say that in the third case, the best way is to basically follow the reasoning. So we asked the large language model to give us some reasoning, so you can read over it and you can try to understand if it is really the thing that you wanted. On the other hand, it is rather an interface for technical people, but you can also integrate this into a more chatbot-like scenario where you do not, in fact, see the Sparkle query. You only see the result itself. And then what you do is that to have some interpretability, you ask a language model to convert this Sparkle query into a textual representation. So he will say, you will ask the same question, then he will say, here, I found all the projects in Malta in a certain fund. And so you know, because it is one independent on the other, that the language model created a query that has this meaning. So you have kind of a feedback that probably what you got is the thing that you expected.
Very good. There is a follow-up question.
Okay.
Okay. So you make it look very easy. Is there anything that you could say, some learning experience, something that sort of an issue that you really, sort of had to work hard in order to overcome?
I mean, it is not easy at the beginning, and also, I mean, it is our expertise to arrive to this point. There are many technical challenges. I don't know. For example, if I bring the part. One technical challenge that I mentioned in the last step is you see this and you say, oh, it's very easy. I take my graph, I pass it to a language model, I say it generates a Sparkle query. Yes, but then it will not scale in production, because basically every second query is wrong. And this is not production ready. This is not what you want to have. So you need more than this. And in this case, one of the tricks is that you cannot really retrain the language model because it's too big. So what we do is something like few shot in this case to basically show examples to the language model. This works very well. And overall, you need an infrastructure to make this quick, because you want basically so you want to load a graph, ask a question, oh, it's wrong, correct it, give feedback, then iterate and go something like this. And then you say, okay, I'm happy. Now let's expose it. So it is, you want to have it easy at the end, but of course, when you start, it is not easy.
Thank you very much, Dennis. Thank you for your presentation. Very interesting use cases.
Thank you very much to Dennis. So now, thank you. Now we're getting into the panel discussion, so I'd like to very quietly ask our panelists to come to the stage. And in the meantime, the audience, please bring out your phone, because I have a Slido question for you. So you've heard so much presented today and spoken about today, but what really is what makes you interested and what we should hear more about and talk more about. So please let us know what you think we should be focusing on with the panel discussion from everything that we've discussed today. Now don't be shy if you see it going across and there's lots of other people. Just vote up. We've definitely got a lot of cross-sector and cross-border data exchange.
Okay.
AI and semantic interoperability. So for the panelists, just be prepared a little bit for some of these. AI-ready data, absolutely. Digital sovereignty. I think we need to talk about that a lot, because this does impact many things of what we do. Okay, thank you very much, everybody, for participating. Marcello, can you tell us who is our amazing panelist?
Thank you.
On stage?
Thank you very much. Thank you, Brooke. So I do have the questions regarding, obviously, cross-sector and cross-border data exchange, but I would like to start from the beginning with one point that Edward made at the very beginning, but I would like to ask to all the panel. So I'll start with Edward, but then we'll move across the line. So he mentioned a research from McKinsey regarding obviously AI. No real value has been somehow generated so far. Then you made another point regarding, the end goal for AI, at least here in Europe, is to connect data spaces with AI and data space with agent. But this is still not happening, at least now. So the question is, what's going on? Is this AI only a hype? Are we moving in the right direction? Was it stopping us to make it useful and to connect the data spaces with AI?
Sure, thanks, Marcello. So I think that just to interpret that McKinsey data, it was the majority of organizations had not seen benefit from it. So they had seen benefit in terms of customer experience, employee experience, and around innovation, but the majority of organizations had not seen that yet. So I think what we see here is that we need to think about not the technologies, but the problems we're trying to solve with those technologies. And actually, I think it's been great looking at this panel where we actually have identified, at least for this, let's say, more technical, data-oriented community, that we do have particular tasks that we can see the benefits of AI trying to solve. I think the challenge will be understanding how the technologies can transform and make our organizations more competitive. So not just generic use of ChatGPT. Anybody can use ChatGPT now. There's no competitive advantage to that or to Copilot or to these technologies. But where the competitive advantage will come from will be identifying, how can I use those technologies to take my proprietary organizational processes and make them more competitive, make them more efficient, make them more reactive to maybe customer needs or to citizen needs. So really embedding and transforming the organizations that we have. So I think the big challenge that a lot of those organizations will now see is that there's a change management process that needs to take place and probably a rethink of what their organization needs to be, we'll say, an AI adopter or an AI kind of centric organization. So I think that's the real barrier that we all now need to come over. And that's where opportunity is created as well. So when we talk about the AI race, I would say if there's an AI race today, it's an infrastructure. Let's keep building infrastructure and hope we can do something with it. Where I think we need to go now is to not worry so much about the infrastructure, because I think those decisions are made. We can get access to infrastructure, assuming you have the resources in terms of money to do it. The challenge now is, well, how will this change your organization? What new things can we do, or what new value can we derive from these technologies? And that's where, at least from that survey, it would seem like the hyperscalers and all those other organizations that are leading the AI charge haven't solved that yet for the majority of organizations. So there's lots of opportunity there. Your second point on connecting our AI strategy and our data strategy in Europe, I think we're getting there. I think what's really positive from a European point of view is that we had our data strategy, we had the AI Act, and I think both of them were trying to do the right things. And I think now when you look at the data union strategy that came out last week, we can actually see we are pulling these things together. So the convergence is starting to happen. Probably need to do it faster, but I think the opportunity is still there, and I think we're definitely heading in the right direction.
And I think, Penny, I think this, especially in your project, it's like the basic, connecting data spaces with AI, right?
Yeah. Before going into that, just to answer the first question, because I think that's very important. I absolutely agree with Ed. I would put it in one word: skills. We need to have the skills to learn to use the AI. It's out there. We're still experimenting. We're testing like small children. And we need to learn by ourselves or be trained by others on how to use AI. This is very important. This is one thing that Ed said, but I just wanted to phrase it in this word. And I see another thing that came in one of the answers that we had in the slide in the beginning: reliability. Right now, AI apps are not reliable enough. Okay. As for connecting data spaces to AI factories, I think this is also coming. There is a lot of discussions right now going. There's a buzzword, data labs, that has come into the play. Until now, data spaces were mostly focusing, in my view, on data exchange, data collection, and making sure that we can exchange them through the data space protocol. Services were not there. And, well, there were in the beginning the IDSA first architecture, reference architecture model. You had the App Store, and that has gone in the later discussions. I think this is coming up again from the other side with the data labs, preparing data and connecting them to the AI factories, AI applications, training models, whatever we call them. So this is going to come in the very near future, I think.
Very good. I apologize, Lorenzo and Dennis. I would like to skip you for the moment and go to Leyla. So how do you see this connection from data spaces to AI and this evolution of use cases to bring value in the large sense?
I think that that I agree with what the speakers before said, that people need to learn certain skills if they want to use AI just in general. And even though me as a data scientist, I have a great grip on how I can use AI and how I have to use it in different business cases. But I think if within the future, within that, I think that data spaces can really help in a way I think in certain on certain cases where you can actually learn a little bit better on the model, because I think that with the challenge with large language models is that it's based on a lot of data. And it's not specific on a certain case. Like, let's say that the government data, it's very complex. It has a lot of business rules, and it's based on a different law system, where the large language model cannot really always adapt and understand that. So I think that if we look to the future within that with data spaces, I think that it can help. It can help definitely, but at the same time, I think we as people, we need to learn first exactly that how we use AI, because still not everything is, you cannot, I say that, you cannot find a solution for every business case with AI. That's also something that you need to be aware of and just not put it on every case and that's it. Because there's still a part of machine learning in a way, which is very important still. And not everything is just with AI. So that's the way how I see it.
Thank you. I have a technical question for the remaining panelists, but perhaps Brooke wants to chip in first.
No,
it's okay. So it's for Lorenzo, Dennis, and Hannes. So we're talking about ingesting documents and large volume of information. Obviously, there are limitations to the model that we have, and the documents tends to be truncated. Either because the token has been, the maximum limits has been reached, or for other reason. So the question is, how do we ensure that the documents, that we ensure continuity in the learning from that particular ingestion, rather than creating that sort of truncated part and just do a summary of that one and learning about this one, and not necessarily the following part. I don't know if my question is clear enough, but it's a very practical example, and perhaps Lorenzo, you can start.
Yes, yes. So from our experience, so we know that the large language model has limitation in terms of tokens. For example, Llama has a limitation, if I'm not wrong, 128,000 tokens, more or less. So how many pages? Depends on the amount of text. So we know from our experience that when the text is quite dense, we may talk about 150 pages. And when we have less text, maybe we can say up to 250 or 300 pages. So in our exercise, we were lucky because only in a couple of cases we had this issue. And in particular, for our cleaning task, we need to remove the last part of the document, because that in general is the reference section. So we were lucky. So in our case, we don't have this issue, but I believe that it's quite a challenging part.
So thank you very much. So Dennis and Hannes, do you find that this is as an issue when ingesting the information, and how do you solve them?
My answer would be it's kind of the engineering part of a typical RAG pipeline, so you have to adapt it based on the use case. It basically depends what question the user wants to answer on top of it. So let's say if you want to summarize a document, you cannot chunk it. He needs to see it all, because otherwise the summary will be crap. If the user searches mostly for specific information, I don't know, a date that is mentioned somewhere, then you can do small chunks and it's fine. And then it's always a trade-off. So you have to have a language model. I mean, if you do a typical RAG with 128,000 tokens, that's a lot. So you can put him a lot of context. So that's very good. On the other hand, you have also then to add latency, in the sense that for each question you have to wait much longer. Maybe the user doesn't accept it. So there are technological boundaries, and you have somehow to swim around them to address the use case in the best way that you can. And it's part of the engineering work today for this type of models. The other way would be to do it more in an agentic way, so to basically allow to the language model to make subsequent searches, to select documents. I think we are more at the beginning there, but that would be more or less my answer.
Thank you. Hannes?
Yes, I mean, I can just Yeah, I totally agree to what you just said. I think it is in fact a limitation, and if I could wish something, obviously it would be to just load like whole document database into a context, but that's not how it works. So this is when the engineering starts, and it also doesn't just start with the token size, because typically results just get like blurred and inaccurate when you just have huge contexts. So this is just part of the engineering tasks that we need to solve and part of the challenge when we want to use this technology. But the good thing about it is that I would say in a lot of use cases, this can be solved by engineering. So for example, when you have query systems, when you have RAG systems, typically you don't need a whole document or a set of documents within a context to answer a query. Just to provide an example. For other problems like generating summaries, it turns out to be a little bit more difficult because it's an abstraction problem. Let's formulate it like that. So yeah, it is a limitation, but that's what engineering is for as well.
So I have a question for a lot of the panelists here. Just linking in, we're talking about the technical element of deploying the AI, but we have to think about the data that we've ingested beforehand or would like to ingest. And this sort of leads into the issues that have come out in presentations about data standardization, AI-ready data, etc. And I can just see that it comes across most of the presentations that we've had. So I'd like to hear from the panelists on how data standardization or lack thereof has impacted their work or impacts their development and potential then deployment of it for use.
From my personal experience as a data scientist, we know that the 90% of the work is the data cleaning, so the data standardization. And so if we are not able to pre-process the data, we can say that we cannot proceed with the rest of the work. So it is clear that when we have such kind of problem, we have to find a solution according to the context, that maybe is chunking. If we want to store the data in a large collection of data in an embedding database, or if I talk about my case, I need to load all the documents, because in the pre-processing stage, I need to clean, to remove part of the text. I applied in a couple of cases the traditional approach with the traditional NLP approach to remove double space, to remove strange characters. So according to the task, there are several solutions that we can apply.
Yeah, I would say the same. So in fact, it is very dependent on your use case. I mean, if you want to do something like text to Sparkle, you need to have nearly perfect data. And because you're basically querying a database. If you have another use case where you just want to plug something into a language model, then the language model can come around it, so it is less important. So also there, globally, bad data in, bad output out. I mean, we can formulate it with other words, but this will not change. So yeah, it's a lot of work. It's in projects, it's a lot of work. And I would say even maybe to enlarge it a bit. So you have a project, okay, you have the data quality, let's say it makes up 30 to 40% of the project, then you have the technology part, and then you have the human part. And the human part is as challenging as the data part, I would say, for many reasons, but yeah, that's important in a project.
I'll speak now from the language data space experience and all the language data sharing infrastructure we've had before. If you want to train a model, you need data. You need as much data as you want, even if it's not standardized. We're asking people, organizations, etc., for any types of data. If it's not standardized, we're going to find a way of preparing them, of cleaning them, pre-processing, etc., so that they can be used for training models. If it's not us, it's going to be some other organization that will do that. It's extremely important, first of all, to get the data and to get them with the proper policies and licenses that will allow you to do that. You'll find a way of transforming it into the way you do that. And once you transform it, as I said before, it's important that you keep not only the new process data, but you also try and describe and reuse the tools, the methodologies that you have used for that. Yes, we want standardized data, but it's not out there. Remember when we had PDFs and scanned images and people were saying, I can't use it. We found a way of improving the quality of the scanned images. We found a way of converting PDF into TXT. We found a way of having standardized CSV formats and using them. It's going to come. We need the data, whatever format they are.
Hook up, oh, please.
Well, I was going to add that I think, so in many ways, what AI is allowing us to do is to bypass standardization around certain things around semantics. It gives us tools to be able to work despite the fact that we don't have standards in the space. But when I think of where we need to go next in standardization, like thinking back to that McKinsey report, like the challenges around data quality, data governance, the management of data is an area that doesn't have that much standardization. Now, this particular community has done very well with DCAT and extending it for AP and ML DCAT AP. And I think that potentially becomes much more important in the future, because that's something that you can't get around, because there's a legal requirement, there's a governance requirement there. So in addition to the comments from the panel there, I think it's important that we figure out, in order to standardize the governance of our data and our AI that we create from it, what's the additionality that we need to put on? You know, so if you look at ML DCAT AP, what do we do beyond that? What's needed to implement the Data Act? What's needed to implement the AI Act in a way that then it can be shared, so that when we do have an AI-ready data resource, and I pass that to Penny for use in the LDS, she knows what the constraints are. She knows what the data government requirements are for that resource. And I think that that's something that would help us all if we can do that as a community.
And what are the characteristics of AI data ready?
That's a good question. So typically, it's not a case of AI data, it's a case of AI ready.
AI ready data.
AI ready. So like, it's actually very similar to any kind of data in terms of, well, do you know the structure of it? Do you know what the semantics of it mean? Do you know what the licensing are? These are familiar terms to us. Do you know what the biases are in it? Do you know, and like bias is also a term for signal. You know, what are the signals that I can find in this? What are the signals I shouldn't look for in this data set? So it really is enhanced documentation. And then understanding consent and usage, which ties to the license, but it is a broader concept than just a license. You can release data, or you can have data under a particular license, but if you're using personal data, or if you're using data from multiple organizations, well, have you consent? So do you comply with regulation? So I think it's a natural extension or increment over the existing kind of data management practices that we would have.
And I mean, we're talking here about the cross-border data and exchange and gathering and cross-sector, because we've mentioned a lot of sectors here, the legal sector, the health sector, etc. How are we actually finding that applied, or the barriers that we find in those areas? Because we may have a country that is very advanced, like the example that we had in the Netherlands, which was great, but we may find that one country requests some more support. So where are we finding the good practices and the practices where we can support in these, to support a community cross-border?
I'm trying to think for cross-border practices. Yeah, cross-border exchange, sorry. Legislation is important. Data Act, AI Act is all over the EU. It has been also put into the national legislation, but that is also something that needs to be improved. I mean, as language data space, we keep asking people for, as I said, language data in their languages, in their dialects, etc. And we're designing a data space where people from England can get data sets from Greece, etc. And they're having general policy, but we also want a contract, and you want to be sure that both the English and the Greek legislation would allow you to exchange them, and that's tough. That's tough. If you want to be legally compliant, that has to do with the licensing. We need also contracts for humans. We also need them for AI applications, etc. But you also can get best practices. I don't know, from other countries. Yes,
we had an interesting...
I don't know where to find them, to be honest, when it comes to countries. When it comes to sectors, it's a bit more different, because you can see the more advanced data spaces and you can see the best practices. GSSC is doing a marvelous job with the blueprint and the toolbox and all the tips that they're bringing there. I think that's also important. Yes, that's what I would say in general. There's no, to my knowledge, there's no single point where you can say, go there and you'll find the magic recipe.
Dennis, yes.
I wanted to somehow maybe try to connect the two questions. What is data that is ready for AI, basically, and how can we create data that is interoperable between countries? So basically, you take a data set and you want to solve a problem. And then you put a human in front of it and you ask him, given this data, can you solve me the problem? If you cannot do this, then the data is crap. Because if the human is not able to solve it, the AI is not able to solve it. And data scientists are very good at this, because they take the data set, they give some results, and then you say, but what is this, why this came out? I say, I don't know, and this is what this came out. So data scientists are very good at taking a piece of data, not understanding it, and trying to get out something, which... yeah, okay. And if we take the example of the data space, it's very similar. So you would like to have data that is interoperable for a certain sector between two countries. So if the two people of the two countries of this sector meet and they can exchange data, so they have this piece of data and they both understand it and can do something with it, this is basically the measure that you have to use. I mean, it's a bit simple, but by experience, we do like this.
And when preparing... Lorenzo?
From our experience, as you remember, we tried with you this exercise to align the different data model. So probably large language model can help us to align the different schema and improve the interoperability across member states and sectors.
On the other side, Penny tried to convert some models from one model to another?
Yes, we're working on that, and I think that's one of the things to do as well in semantics, doing it with language models or on your own or by humans. This is something important. DCAT-AP, GeoDCAT-AP, not even standard models out there. We need to speak also the language among us, the metadata schemas. Yeah.
Clearly, we need a validation, not as mentioned. So we need, it's a starting point.
Mm-hmm. There is also another problem that basically, I mean, we encountered it in a project, I remember this very well, cohesion policies, there is a piece of law, the piece of law says every member state is obliged to publish the data about the project that they finance. The following data has to be published, the name of the project, okay, the beneficiary of the project, which doesn't mean anything, the location, then there was a bracket open, postal code, comma, coordinates, comma, city, comma, point. Then it was close the bracket. I mean, this is horror. This is not data interoperability. This is, and then each member state published whatever. CSV, Excel files, different column names, different formats, different types of locations.
No metadata.
So, I mean, there is no consciousness from the legislation side what actually it means to have clean data.
Let me again circle back to the core, which is AI-ready data. This is a question for Leyla, because you were mentioning, obviously, that you find in your data set some biases. So how do you remove the biases? How do you check for the biases first? And then how do you remove the biases so that you can call the data set AI ready?
I think with biases, it becomes very difficult. You cannot remove bias easy from a data set. Bias is always something that you have to be very careful and you need to be aware of it. And especially if you are using certain algorithms that are not explainable. So within our government, I cannot just use a deep learning model on a certain question where I actually do prediction if someone will have more benefits, yes or no. It needs to be more explainable. So I think when it comes to the biases, you have certain, I will say, tools or relations that we have to see if we can go around it in a way, but at the same time, you need to be aware that there is a part of the bias. And if I can become a little bit more technical, it's like what kind of features actually creates that bias, and is it something that you have to take? And I think to add a little bit the question, as a data scientist, yes, as data scientists, we are good in taking the data and then something comes out, and I don't know why, but I think as a data scientist, you will add more value if you understand the domain knowledge very good. So you need to put, like me as a person, I put a lot of time in the beginning of understanding the data and sit down with someone from the business, tell me how this data is actually structured, how this data model is actually being built, because most of the question, the question of like what kind of data is good for AI, I think it starts like that organization did not have I want to say the common sense, but it did not have the idea that in the future we will use this kind of AI models. So we just build this data model the way how we think we use it, and people just registrate it, and that's it. But over time, we see that technology going fast and fast and fast, and we want to actually experience like what can AI do for us. And for me, AI is still a definition of machine learning and the deep learning models and the large language models. And then it becomes quite difficult if you have a historical data model that has been built where you cannot easily actually, as a data scientist, take all the features out of it and just try to do it. So I think with bias, you need to be aware of it, and you also need to be very clear and also honest, like this is something that I cannot actually get out of the data. So is it something that we need to continue, yes or no? One of the things that I do a lot with the board members, telling them, like, I understand that you want to understand what AI can do for your business, but at the same time, you need to be aware that we have certain biases in that, and we are an organization where we're helping people to get back on the labor market. So you need to be very carefully on which kind of topics you use different models, and be also okay with machine learning, because it's more explainable and you can understand it a little bit more better than go on the hype of, I want to use AI, like, hey, I use AI for this and this and that. So I think it's like a bigger picture where, yes, a data scientist needs to be aware of the bias, and at the same time, it's not possible to take the bias out of the system. It's there.
Before continuing, because I would like to give the words to Hannes for the very same question, but I want to keep asking Leyla, perhaps, or anyone that wants to chip in, can a model infer the intention from the data rather than using a data scientist, that try to understand the data? Can we not ask a model itself to hey, tell me what you know, what you understand? Hannes?
I'm not sure if I get the question right. So the question is whether we can use basically the data by itself to infer what's inside?
Yes. The model, the Gen AI is used to generate information, right?
Yeah.
Not necessarily to label it, right? So if you feed him with a model and you're just simply saying, hey, tell me what are the basic logic, instead of spending time with the data scientist and trying to figure out what the data modelist wanted to say with that particular model, can we not use Gen AI? Can we not?
We can.
Right?
So definitely, I think it's part of the solution space. We can. Nevertheless, I still fully agree with Leyla that as a data scientist, we need to understand the data we are working with. So in some cases, it's totally fine to do exactly what you just propose. And I think that's a concept that is present in data science for forever, basically. It's about finding hidden patterns in data, right? So it's a similar problem type. However, it doesn't take like let's say the responsibility from us to understand what the data is about, what's inside, and actually also with Gen AI, we cannot just say, okay, now go and have a vague problem definition and let it run by itself and improve by itself. I mean, that's also an approach, and it works for some cases, but in most of the cases, it still requires us as data scientists to understand basically what's inside.
Yeah, and to add a little bit on that, I agree with what he's saying, but also the certain business rules that a data model have, it's not really something that generative AI can easily adapt and understand. Yeah, I don't think that you can use generative AI to tell like, okay, hey, what's the data model and what is in that and what are the business rules. I think that's very difficult to get out of that, because before of that you need to understand how you answer that question. So good prompting, good skills to get out of that information, and finding also the right large language model who can understand the domain knowledge where you're working in. So yeah.
Maybe one thing to add there, from my experience, especially when it comes to Gen AI, it typically doesn't happen too often that you have a fully specified and described data model that you can basically then analyze with Gen AI. If you would have that, I guess we would be faster in coming to the right questions, deriving the right questions, and for sure we could use Gen AI to answer some of them as well. But in most of the cases or use cases, we don't have a priori like a fully specified data model.
Thank you. I don't know how we're doing with time. It looks like there is a red. I have tons of other questions. One more. Absolutely. Go ahead.
So we're talking very technical here, and this is sort of how the data scientist deals with the models and how to build the models and go forward with the models. But we're building the models to be used by an end user in a way. And as we've said a few times before, these are case specific. And as such, this can change how a data scientist looks at it. But this sort of links into some comments that we've had throughout the day about data literacy and how this could potentially improve AI acceptance and use and understanding. So you mentioned just before, Leyla, that you had to actually explain to your stakeholders, my model can't do this. That gives a bit more talk time for a scientist to do this. So do you think data literacy and how it could impact in a beneficial way the outputs that you do, and it could potentially support a better end user use in a way? So maybe Ed and Penny can start, and the data scientists, please think about it.
Sure. So I think like data literacy in general is of critical importance, like particularly at a societal level. Understanding, first of all, we talk about bias. You know, in the general population, you know, talking about what is bias in AI, what do you mean? So I think, you know, creating the awareness of how data-driven decision-making takes place, the use of models for decision-making. You know, these are very, very simple things that need to be prevalent in our society. You know, and not a case of just educating the youth, but actually educating everyone at all ages. Explaining the value of your data, the value of your personal data, and again, when people use, you know, cookies, you know, you are allowing yourself to be tracked. So I think if we are to have a true transition towards a digital society, literacy will be a critical part of that. So the better educated our citizens and our users are, the more trust we can actually have in our systems, because they'll have more skepticism or maybe more ability to interrogate and to question and to probe. Is this appropriate? Is this right? Is this what we want our society to be? So I fully agree with that.
Good. Any other panelists?
Absolutely agree. We said a little bit in the first question was about the literacy for models, the skills that we said. We also need that for the data. It's important. I think it's easier if we think of sectorial data. It's easier for us to know the data that we are using in our work, business, etc. If we start by that and we get trained to understand, because we understand better our own domain data, it will be easier to understand also the other domains' data and see how they can be used for training models, for creating AI applications, etc., and getting the benefits of it. Yeah, again, training ourselves is, I think, a very important key element in AI literacy, if I may say.
Yeah, maybe one thing to add, because I think that still there is quite like a misconception about what LLMs are, or I have the feeling that from discussions a lot of people take it like as a fact what the outcome is, but at the end of the day I think it's super important to have the users also like educated, that at the end of the day, depending on the model, but for Gen AI, it's, for example, it's a probability for word sequences, right? And that's it.
All right. I will have, if the audience can spare for other 3 minutes, and the event itself, I have the final question, and it will be hopefully a quick round. I'll ask the panelists to go a quick round. It's an opinion. Obviously, Edward started or finished her presentation with a lot of questions. I cannot ask them all. But to sum up, and the questions that I think is in at least the SEMIC mind is, can AI help for semantic interoperability? If yes, how? Briefly. If not, why? I accept the answer is yes, a little bit. Please.
I think absolutely. And I think Dennis showed some great examples of AI being used for interoperability. I think it's the biggest power that it has is in that kind of computational semantics side, where it can interpret for us, help us ground meaning. So that when we're all looking at the elephant, if it can explain to me what your elephant looks like to my elephant, I think that can help build kind of collective awareness of at least what our differences are. So I think there's a lot of opportunity there and a lot of research to be done in that space as well.
Ben?
Yes, I think it can help. As I said before, I would love to experiment a little bit with mappings of metadata models, but I would love to experiment even more with extracting knowledge, mapping knowledge, finding synonyms, etc., from data itself. That would be also something to look forward to in the future. Yeah.
Hopefully near. Lorenzo?
Yes, of course. So I mentioned before a real example on how AI can help the cross-border or cross-sector interoperability, but I would say that AI is a tool, so we need is a support for us, but we need to control the result. And I would say that AI can complement the human expertise, as mentioned by the other colleagues in the domain.
Thank you, Lorenzo. Dennis? I would say partially, in the sense that interoperability, it is mostly about people agreeing on terms and standards. And to reach to this agreement is a very important step about interoperability, and there AI cannot help. So the people needs to sit together and arrive to some common standard. Once this common standard is established, then you can use AI to basically make conversions and to make linkings between them. But we cannot fundamentally think that interoperability will be solved by AI. This I don't believe. Leyla?
I do agree with him, specific in the CompetentNL that we did. 2 different organizations comes together and need to, a certain word needs to cover certain topics. So yes, it takes time to get there. I think that semantics, in a way, from a mathematical perspective to a large language model, it can help because it brings relationship within words. So you can see that it can give better outcome. But I totally agree with him that it's partially because it takes also a human being or human just to connect and to make it for the AI, not that the AI is making it for us. So, comme ci, comme ça.
Thank you. Hannes?
Yeah, I mean, interoperability, as you defined it, right? Defining an exchange format, for example, like definitely no. Or from my perspective, I would say no. However, I say still say like it's a full yes, because there are still a lot of cases extracting structured information, transforming schemas one into another, creating a schema, processing like legacy data into a format that you agreed upon, like for an exchange format, for example, where you could use AI to, and it facilitates a lot the overall process, despite the whole, let's say, communication, coordination, agreement, negotiation about how this exchange format would look like. I don't see it to be solved with AI.
Okay.
Okay, I want to thank the panelists for a great discussion. So thank you very much.
Thank you very much, and a very interesting conversation. I think we learned a lot. We went from being perhaps a bit more skeptical, there is a lot of work to be done, to yes, AI can help, but with supervision and with help from the human. So I was hoping for the other way around. So it's a human work with the help of AI. Now it's a AI work with the help of a human. So this conundrum will probably not be solved very quickly. But thank you for all your opinion. Thank you for the audience to resist for so long. And have a nice evening. Thank you.
Thank you.